All right, good morning, everyone. So the past month or so has been very exciting from my standpoint, as I had the opportunity to really dig in and understand what Langchain brings to the table. And so I've got what I consider to be a very good introduction to the what goes into it, the core concepts, and then the last hour is 100% hands-on understanding how the framework works and how to use it to do interesting things. Let me go ahead and share my screen real quick. All right, that looks like it's pretty clear. Go ahead and box in me. There we go. All right, so to kind of get us off on the right foot, ironically enough, language is very important. How you describe things and how you think of things goes a long way towards either improving your understanding or not about things that you look at and see every day. So this has dawned on me over the past week. The tool that we're going to be using, that leveraging, is I still call it a large language. I still refer to it as a large language model. It is a large language model. Functionally, it predicts the next token based on the preceding number of tokens, but that's a very dry, boring way of describing what it does. So I've twisted a couple of words in my head, and it's really helped me to understand the capabilities and the direction that we need to go to get towards an artificial intelligence that's useful. So we used to talk about LLMs being chatbots. In my mind, I now label it as generative AI. Now, unfortunately, AGI has already been taken, artificial general intelligence, and GAI doesn't really roll off the tongue very well. But when I think of this technology, I think of it as generative AI. We used to talk about having chats or just having chats. We're going to leverage a different aspect, a different capability of these large language models, and that is cognition. Because they can answer questions, they can draw conclusions. And it's that capability that we're going to draw on heavily to take this chatbot concept to the next level. And so if you look at an LLM as generative AI and chat as cognition, Langchain is the tool that allows you to create what I call to myself directed cognition. Setting up scenarios in a way to leverage that large language model to answer a question or to do something useful. Here's kind of the general layout. The timestamps are rough depending on chat and feedback. We can go as quickly or as thoroughly as we need. We'll start by a quick review of state of technology with a focus on locally run models. And then I'll just take a few minutes showing you how I'm setting this up using text generation web UI to not only run the model locally, we'll go through a scenario of running it on the CPU as well as on the GPU, which can run tens or hundreds of times faster. And as well as setting up this same tool to pretend to be OpenAI's API endpoint. So Langchain and almost everything else out there right now is designed around OpenAI's API, which is great. Hopefully by now all of you have signed up for a free ChatGPT account. Access to the API is charged 5,000 token increments. But we can run a language model locally and then tell Langchain to use that local model using the same API instead of writing checks to OpenAI. So I'll show you exactly how that's set up. After that, we're going to spend a couple of minutes showing you, just using text generation web UI, how some of these concepts work out, how you can use the language model to answer a question or solve a problem. And then just a minute about where where I think or where I'd like to end up over the next couple of months. And then we'll get into, at the 45-minute mark, the basics of Langchain, core concepts, the different hot and happening areas of research right now. And then the last hour is all deep dive. So I'll walk you through from start to end exactly how these pieces fit together, and then as far as I've gotten with stringing them together to do interesting things. So at any point, anyone has any questions, raise your hand, see my name a few times, and I'm happy to answer any questions that I already know the answer to or help figure it out with you. Okay. So moving over to the web portion of our presentation. By now, if you haven't already, sign up for a free account for ChatGPT. It's a great way to get your feet wet and just see what these models are capable of. ChatGPT or GPT 3.5 and GPT-4, OpenAI is considered proprietary. They haven't publicly released any information about the number of parameters or how they work. But we'll get to a leap in a second. ChatGPT or chat.openai.com gives you access to a simple chat interface. If you pay for a Plus membership, it gives you the option of bouncing up to 100 queries off of GPT-4 every hour. And it looks like I was just cleared to use the chat with images feature. That's awesome. And then separate to that, there is a whole other interface called the Playground. So the Playground opens up a few more fields as a large language model user to tweak, to experiment and get different results. You can play with the system prompt to get the responses in a certain flavor. You can still add messages in. It gives you an option to tweak the max sequence length and temperature and stop sequence. For those of you who aren't living in large language models, temperature is just an analog for creativity. The higher the temperature, the more creative the responses. The lower the temperature, the more matter of fact. And so what's the right temperature to set? To be honest, it depends on the situation. If you're just having a fun chat where no knowledge or facts need to be exchanged, set it up to a 1 to get a really fun, engaging conversation. If you're interrogating the model for information about anything, something factual, you'll want to turn that temperature down to 0 or 0.1 or 0.01 or up to as high as 0.2 to more stick with the facts and be less creative with its responses. So, getting back over to what's inside these models. Someone spilled the beans on how GPT-4 is set up and how I believe ChatGPT is set up as well. Most of it seems to check out by the experts that know a lot more about this than I do. One of the biggest revelations is that they're using a technique called mixture of experts, which means that the whole GPT-4 model may have up to around 128 trillion parameters, but they've subdivided it into what they're claiming 16 different experts. Which ends up being, I thought it was 180 billion, but the way the math works out here is 111. So each expert has been trained and fine-tuned on a different type of conversation. One for coding, perhaps, one for facts, perhaps, so on and so forth down the line. They don't provide any more detail in the leak about what each expert is. And then there's something in front that routes that interaction in the conversation to the correct expert based on the context of the content of the question. Personally, I think ChatGPT is set up the same way, just based on the quality of its responses. Again, I'm just guessing, but based on their pricing model, it looks like each expert is in the 20 to 30 billion parameter range, just based on how the math works out, based on the last known model, Da Vinci being 175 million, and and the pricing based on that. Now, the way the pecking order works for language models, and I'm not really tracking Google Bard or Claude or any of the other ones. GPT-4 is king of the hill for capabilities in language model. And when I talk about capabilities, it's not just its ability to answer questions and be factual and hallucinate less. Its ability to understand and pull patterns out of interactions is cut above. And now that it supports vision capabilities, getting a picture, it's even better. The example that I give to just, because it's kind of hard to wrap your head around, well, GPT-4 costs more, how much better is it? There's a guy out on the internet named Kaze, and his hobby and his life right now is understanding and optimizing the architecture and framework for the Nintendo 64 game console. They're like, that's pretty niche. Well, it is. He's probably the only person on the planet and the most knowledgeable person on the planet about not only the hardware, but the software, the programming environment, the RISC processor, the reality flow processor. I can't think of anyone who would be any more qualified to talk about this. This is the guy that disassembled the source code for Super Mario 64 and then optimized it to run twice as fast on real physical hardware today, right? This guy is at the top of his game, just to give you an idea of where I'm coming from. So about 7 months ago, he released a YouTube clip where he paid for access to GPT-4, and he was having a chat conversation with it about the source code in Super Nintendo 64. How does this function look? Is there any way to improve it? Is there any optimize it? Now, GPT-4 was not always right, and it wasn't always smarter than him. But the fact that GPT-4 and its corpus of training, the amount of information about N64 programming, like what fraction of what percent would be in that, and still it was able to hold its own in a conversation about the esoteric details of optimizing Nintendo 64 code. It held its own with a master, a god, a deity-level programmer on the subject. So when we talk about GPT-4 being a cut above, those are the things that I think about when explaining the difference between ChatGPT, which is still really smart, and GPT-4. ChatGPT is maybe a junior level developer when you're talking about pair programming and source code and stuff. GPT-4 is a veteran expert in any programming language, anything at all.
Yeah.
Yeah.
I wonder if it would do as well in a liberal arts topic, for instance, that isn't as much on the internet, like say 14th century French literature or something. Would it be as good as the expert in that field, in the fields, because of programming and all that is been online for years and years.
Yeah,
other things are not so much.
Yeah, it's a good question. I wouldn't have the background to fact check it on it, but I would expect that it would be just as good or maybe a little bit better, because online are the summaries, the treatises, about it as well. So as long as it's on the internet, it probably has seen something. So I would expect similar results. Yeah, for sure.
I'm just saying, the amount of data, like detail on the internet is more for IT, for information technology, than for other topics.
Yeah.
Or engineering. It does pass all the major tests, right? The AP exams, the MCAT, the GRE, it passes all those, which are kind of broad, but there's a lot of study material for them.
Right, but they're not as deep, like.
Right.
I'm talking about PhD level in French literature, or something in the Middle Ages, versus, which is, I would say, equivalent to this Nintendo 64 deep dive, because that's really, really specialized.
And if it's getting things wrong, it's probably more pulling on an assembly background in general than specific. So, because assembly looks like great to most people. That you programmers that don't do assembly.
But it still has that in its.
So, the state of the art in large language model changes almost weekly. For the publicly available models, a good place to look to keep track is the Open LLM leaderboard that Ben has posted a link to in the chat, and it's always fun to see who's on top and why. Let me small this a little bit. And generally speaking, most of the fine-tuned 70 billion Llama 2 variants will be the top of the food chain. And they all are like, on average, their scores were a little bit higher by a point or a half of a point, but I would consider them all to be about equivalent. What I did is I went ahead and grabbed a couple of items from note and put them into Excel. That's fine. Hey, I'm good, I'll sign in later, it's okay.
They keep pestering you, Microsoft, did that to me this morning. So
here is the ones that I'm currently tracking in space. Again, the 70B ones are the absolute smartest. On average, they start out at 66 with the plain chat model and go to about 73 for the Platypus 2 fine-tuned version. Super, super impressive. And up until a few weeks ago, the Vicuna 13 and 30Bs held their own pretty well. The Llama 2 variants all held their own respectively. The 7B chat had an average score of 56. Surprising to me, the Code Llama variants, the ones that were fine-tuned on programming, I guess not so surprising, they score a little bit low on the standard suite of tests, but then if a test was programming specific, they would score a little bit higher. So the new kid on the block, the one that's getting everyone excited, is a wholly created model that's not based on Llama 2 called Mistral. It's a 7 billion parameter model, and the Mistral model itself, out of the box, is within spitting distance of the 70 billion parameter models based on the standard texting with text evaluations, which is really impressive. However, if you fine-tune it, and the first fine-tune that I've decided about was OpenOrca. Microsoft published an Orca paper that described the qualities of their data set. The source community gotten around with it, and so now they are fine-tuning existing models with the Orca approach called OpenOrca. And just yesterday or the day before, the Dolphin guys said, hold my beer, and fine-tuned their version called Dolphin. So OpenOrca is a fine-tuned data set with guardrails, so you can't ask it to do anything bad like break into a car. It has the same safeguards that a lot of the other models do. The Dolphin guys are like, you know what, I want a model to be honest, so they stripped out all of the safeguards in the alignment prompts and responses, and so they call theirs Dolphin, which is a smaller Orca, I guess. And look at that, a 7 billion parameter model is punching so far above its weight that it's holding its own with everything but the top model. And so this is the one that I've been using and the one we're going to focus on. And this is one that you can run on your graphics card if your graphics card has at least 6 gigabytes of RAM. And so that puts it well within range for most users if you've already built a gaming PC. And you can also run it on your CPU. The CPU will run about 10 tokens a second. So not super fast, but what that means is you can run it locally even if you don't have a graphics card.
On I'm sorry, did you say where Mistral is built? Was Mistral built from scratch, or it wasn't built on top of Llama 2 or anything, right?
You know, that's my understanding here. Let's fact check me really quick. Sometimes
it's yet another original open source, or I mean, not from the leak of Facebook's or anything. Right, yeah.
So my understanding is that it wasn't based on Llama 2, but if I missed that or they hit it.
And when, right, okay, let's assume that's true. And then the fine tuning is just different. Oh yeah, how do they get rid of the guardrails? And in this case, if it was trained from the beginning, then, and it was all open source, then they could just leave out. Unlike like Llama 2, which already had guardrail, or Llama,
built into the
where you
training,
have to undo, which is harder to undo things.
Yeah, and the Mistral 7B doesn't have any alignment baked into it, so you can ask it weird questions and it responds truthfully. OpenOrca baked some of that alignment back into it, and then Dolphin, their data set doesn't have any alignment prompts and responses in it, so it's just as honest as Mistral is. And so I've got a theory on this. I quipped about it in a message post, I think, last month, is that when you're training a large language model, you're giving it to the opportunity to identify patterns in the data that you feed it, right? And generally speaking, the larger the number of parameters, the more the patterns it's able to figure out. And it's one of those things where you can't look at a model without running it, or look at the training data, or look at the architecture of the neural net that was going it, and figure out anything about it. It's not like you can look at the makeup of a model and say, you know what, this will be better at math, or look at the resulting trained large language model and say, you know what, this will be good at French. You can't figure it out from how it's built. You can't really figure out a lot about how it's trained. You've got to test it, which makes it unique compared to writing code for anything else, where you write the code, it works or it doesn't, and when it doesn't work, you figure out why. So when I see things like the 7D model being available for home use, I'm seeing a rich opportunity for tinkerers just like us to discover something new and interesting. And for the past several years, every time someone figures out something new to do with large language models, they spin it off into a startup. And it's a little bubbly. There's a lot of people out there in that space that are cruising on that sweet VC money, VC funding, and they're gonna pop. But a lot of the other ones have something going for it. I was watching an interview in Langchain with the CEO of Nomic, and I didn't look up Nomic. I didn't know what it does. I knew they were important enough to be on the YouTube clip. But when this 26-year-old kid goes on and talks about how he started this company, I was a little irked. Not at him, not at Nomic, but probably at myself for, not being as motivated. And then it turns out later, like, it's some huge company that uses large language models and deep learning to identify new protein patterns for like it's a real thing, but I'm like, oh man. So what I mean by all that is that there's a possibility for you to discover a new combination that no one's done before and to do something interesting. And getting back to the Langchain aspect, the directed cognition, whether the Langchain approach will get us to true AGI or is a stopgap before something else, I'm not sure yet. But directed cognition using Langchain to steer and leverage the strengths of a large language model produces some really impressive results that are far more useful than the language model.
I have a question about the benchmarks. So GPT is not on these benchmarks, it's not open or whatever.
Correct.
Do you have a feel or know where it would rank on these? Is it going to be like 100, or is it really close? These top models are getting close to like a 3.5 or 4.0.
And it's a great question. If I would have thought about it, I'm sure people have ran this suite of tests past ChatGPT and GPT-4. My gut's telling me that ChatGPT will be in the 70 range, just because the mixture of experts allows a 30 billion parameter model to specialize in a subject matter and not get diluted. And then the GPT-4, I'm just pulling this out of my posterior, but I think it would be in the low 80s.
Do you think it's
definitely
close?
higher?
If it's close.
Definitely ballpark, yeah. I mean, just based on, you know, a guy looking at the numbers, just like, the larger the model, generally, the more it is able to understand or comprehend or cognate based on information provided. But 7B is proving that fine tuning with a curated data set can result in a model that punches above its weight. According to the stats, this 7B is better than any other 7 billion parameter model. Almost every 13 billion parameter model, and a lot of 34 billion parameter models. It's really amazing. And earlier I had set up a 70 model in the background and a 7 just to see the difference if I had to switch back and forth. I haven't seen a reason to switch back and forth yet. It just works. It just works.
Do they have a 13 billion or a higher one that's even better, or is the 7 the sweet spot?
On the Mistral, not yet. They've only released a 7, but I would be very excited to see the results of the 13B.
Interesting.
Yeah. All right. So if you're made of money or just don't care, everything we're going to talk about later on, you can bounce off of OpenAPI out of the box. Langchain's built to do that, and that's everyone who's developed these tools that we're going to be using and leveraging does that as well. But I'm not made of money, and I really strongly want to see what the limits are in local generation. So I'm going to be running these locally. We've talked previously about how to install text generation web UI. You can pull the repository and then follow the instructions, and you'll have it running in no time. Once you're in the interface, it's very easy to download and use new models. I'm going to switch back and forth for a little bit. And they even, when you're installing the requirements, they even have different requirements for Apple versus CPU only versus AMD now. I guess they needed that for the best performance. And so my sweet spot right now is to use that Mistral Dolphin model using a transformer engine called XLLama V2, which is again a free download. And I'm generating 130 plus tokens a second with that set up on my GPU. If you do want to run the models locally on your CPU, there's a different type of model. With a format called GGUF. This is, if you're running it on a CPU, this is the file and the version of the model that you'll want to run. And people are saying 10 tokens a second plus, running it on your CPU, on your desktop, or your laptop.
So what's the model loader? What's the old, or I'm a little bit out of date, but the model loader, you have a choice there, or what are the?
Oh yeah, sorry, I skipped a step. So if you would like to download the model that works best on a CPU, here's exactly how you do it. Just throw this one in the chat. I can't remember if I gave the link to them. So if you're having this, there's a two-step process. Step number one, just click here. It's almost like they're meeting. To copy this to the board. And then the first step is just to copy that link into the top one. Now, if I hit download, it's going to download every variation of that model. But for CPU generation, there's a certain type of model you want to grab. So scrolling down, you can see they even provide 2-bit models. There's a great reason to run that except to people just to check it out. But in the 4-bit category, we want to grab this guy right here, medium, balanced quality, recommend. So it's the Q4KM version, and when you browse through Hugging Face for other GGF models, they'll have a similar breakdown. In order to grab just the model that you want to use, copy that and go back over here. And so it's a two-parter for the GGUP models, where the models are located, and the model that you want to download. And then you click on download, and it grabs just that one model. All right, so we're focusing on local generation. Our favorite model is the Bloke Dolphin Mistral 7B, which is already loaded. Let me show you how, when you launch text generation, how you can launch it so that you can use it as an open API endpoint. All right, so I'm not running this on my machine. I'm running it on my machine at home, but it's going to work the exact same way after this one step. I'm going to connect over there. All right, so documents. The first file that I want to show you is the launch file. So I'll leave it on screen for a second because it makes it easier just to script it out. And so when I launch text generation UI, I launch it with a couple of different parameters. I want to load in the default model. I want to put it on a separate port. I specify the model that I'm loading as well as the next sequence length. Pull in a local configuration file, and the next is actually right here. There's an optional extension that you can open that tells text generation to behave like an open API endpoint. And once this is running, when you're running Langchain code, which I'll show you exactly how to do in a bit, you tell it to use your endpoint instead of OpenAI's. So you bounce as many queries as you want at no charge.
But it's using the OpenAI kind of extension, and that's like a protocol of sorts.
Yeah, here, let me just see if I can paste that in the chat to make it easier. The next one is the YAML file. There are a couple of things that you can't specify in the command line. And we'll paste those in as well in case anyone wants to follow along at home.
This changes every month. I'm like behind a year now, a year worth of.
And yeah, so there's a couple of things in here that you can't specify. The truncation length was very important. And the long list of things that have improved over the past couple of weeks is, for a long time, the only game in town was able to generate a maximum of 2,048 tokens, so about 1,700 words between what you put as the input and the response. So there was a lot of work put into how to crunch down the information to 2,000 characters to get meaningful output. With the Llama 2 models and ChatGPT, that expanded to 4,000, so twice the room, a lot more wiggle room. The Mistral model was trained on 8,000 characters. So again, we've doubled it again. The code llamas have up to 100,000 characters. As you saw, they're not so great at logic, but we'll play around with a little bit with both as we move forward. All right, so those are the two files. So what we'll do is we'll just launch. Yeah.
How are they doing that? All that GUI in this?
Maybe // and I get the slash backwards. Yeah. I'm gonna zoom the other way.
Where's all
Oh, you know what?
where are those graphics coming from? Isn't this a terminal?
Oh, yeah, this is that fun new terminal thing I posted about this week.
Oh, did you post? I'll read that.
Ah, it's all about the right slash. Thank you. So you run the batch file, it pulls in everything, opens up the OpenAPI API, and then you're ready to rock. So cool. so forth. Let's go back over to here. So right now, I'm running that dolphin model, the GPT forfeit one, using Epsilon V2, and using the script file, it automatically loaded it. Now, if you wanted to run the GGUP version of that, you would, after downloading it and installing it, you would select it. It'll automatically move over to Llama CTP.
So the loader is for different format families. Is that
Oh, yeah.
kind of roughly?
Yeah, this is the Swiss Army knife of large language models. And so you can, and Hugging Face is the de facto depot for large language models, and so they work really well together. What I like about this setup is, in addition to running the OpenAI API locally, you can still run hypothetical scenarios and have chats just using the interface, and they're all separate, something we're going to leverage here in a few minutes.
So you don't really have to worry too much about the loader, because when you pick it, it kind of picks it for you.
For the most part, yeah. If it's a very new model, it may take them a couple of days to update their script. So you expect it, but yeah, so far, yeah, it just picks everything up. All right, so so that's how to get set up. Let's walk through some of the things that they're useful for. Now, we've all used chatbots and had conversations and picked its brain about facts and watched it hallucinate. The thing is that you can get these local language models to make determinations, answer questions, break down the program steps. It's a lot easier with 8,000 tokens. With the Code Llama models, you have up to 32,000 tokens. So this is a really quick example. Let's move over temporarily to, let's use Code Llama 13 because it's a little bit smarter. And it defaulted to a different loader. I actually want to use this loader. Let's say a maximum of 24.
That's input plus output.
Input plus output, yeah.
That's the standard.
Okay, let's exit out and go back in. Sometimes when you switch models around, it gets a little grumpy. So we'll switch to Code Llama. And so one of the things that Jim was showing off over the past 2 months is summarization, right? Taking the text of, taking the text of the transcript of the last meeting and having the system, I'm sorry, yes. Having the system summarize it. So there are some limits right now in large language models' ability to summarize large amounts of text. They found some practical limits to the attention mechanism and rope embeddings. If you throw out a huge amount of text, it sometimes gets lost or goes down a rabbit hole or focuses on the wrong subset. Something that the Meta folks just solved with a couple of small tweaks to their rope embeddings for their Llama models, but up to about 12 to 16, it's mostly okay. So let's set this up. And we'll just paste in the entire part of Jim's presentation about Amazon Alexa and Big Orange. And looking at it, it's stream of consciousness. There's not a lot of formatting. Sometimes it's a best guess about when it's transcribing the audio that it hears. And I'll be honest, if I was just reading this, it would be a little challenging for me to keep up with, just because, you know, it's anything that it heard over the course of the conversation. So,
and I wonder if when I had an actual microphone transcribing here, that is a little bit better than going off the YouTube. Well, the YouTube people are art professionals, but
Yeah, we actually have 3 transcripts to go off
it
of.
is a recording.
So Zoom transcribe, there's a Zoom
Wow.
transcription, there's a YouTube transcription, and then you've got your own as well. It'd be interesting to compare notes, but I think they all have about the same quality and that there's no punctuation and, you know, occasionally.
Oh, we can use Reba for that.
Yeah, yeah.
Reba would automatically punctuate, and you know, the one we've shown before here with the large language processing.
Yeah, yeah. So here, let's paste in Jim's part of the talk, and then we'll just ask it. What would be the title of this talk? So it's going to take a minute to chew through it because there's a lot of characters.
12,000.
And just reading through that text.
Or controlling your home.
Okay, well. Yeah. Chew through, takes a couple of seconds longer. It is bigger. And then finally, right, so this seems useful. So the ability to take text and summarize and pull information out of it seems like.
Downgraded.
Oh. So the one downside about code like Yama is that we saw in the stats, it's not as smart, but it has such a large window that I'll look past it. But being able to summarize larger text into smaller text to provide titles, that seems like a useful thing to do, in addition to having a larger window to provide context and information.
Well, also it provides more, even like it spelled out what MQTT is without me having said it.
Yeah, and so question answering, summarization, and it just does it, and the models are only going to get better as time goes on. You can also start a new chat. What are the different forks? Respond in JSON format. It's able to. Oh, make me a liar. Oh, that's disappointing. It works at home. All right. You can ask it to provide in different formats. The behavior of it is non-deterministic, and obviously I don't have the right prompt to do that. Prompts are very important. The different ways of phrasing the question or the activity goes a long way towards setting up the large language model for success. So when I look at large language models, in my head, I think of them as being at different ages, right? So my 7 billion parameter model isn't as smart as GPT-4 just because of the number of parameters. So my game plan when we get further on in this talk is how would I frame this in a way that an 8-year-old would be able to figure it out, or a 12-year-old, right? You can also pass it passages of text, like pieces of a book or a paragraph, and you can ask it questions. You can ask it a question and then ask if that text relates to a question. Again, these are all things that seem a little bit useful to be able to break down, answer yes or no. Is this appropriate? Does this work? And where I get super excited about all this is, back over here. Getting back to the top is this whole thing, this whole concept of directed cognition and Langchain is your foot in the door to get these large language models to do interesting and useful things. Now, I'm not talking about the work being done for neural nets and AI for practical manipulation. This is just tech stuff, right? But still, this takes it from a curiosity, this concept, to being useful. And Moving forward a little bit, there's two projects I want to draw your attention to. There's actually a lot, but there's so Jim posted about this in May, and while I looked it over, I didn't think too much of it. But it's designed after Stardew Valley. It's looked after. So what this guy did not leverage Langchain, because Langchain's a framework. And just like ROS is a framework, you can do everything in ROS with the framework or without. With Langchain, you can do everything Langchain does without Langchain, but Langchain as a toolkit makes it easier to set up things in a way that the experts have used and determined is a good approach to go from point A to point B. And so this guy made a simulation like The Sims, except he set up a number of characters, he gave them a bit of a backstory and motivations and a schedule and a series of tasks, and then he just sets them loose. And as they go through, he's kind of closed the loop of, like, we're all wondering, like, how do you get it to do something? What do robots do when they're not answering our questions? What does a large language model do when it's not responding to a question or input? There's a hint about what that solution looks like in here. Because when you let the simulation run, and he ran it on, I think, GPT-4? Anyways, he was saying to run a full run costs about $1,000 a day, bouncing off of OpenAPI. OpenAPI's API. But here you have a series of characters and emergent behaviors that result from giving each character a backstory and just letting them run. They go through their routine, they know what they're supposed to do, they bump into people. In one of the scenarios, someone organized a party and invited guests, and like, so if you want a glimpse into what a future of applied generative UI with an agent with some amount of autonomy, I think there are some hints in this guy's work on generative agents that we can leverage. It is, even though it has the look of a game, the thought that went into making this thing work seems like it has real world applications, and I'm fairly excited to dig into.
You said I said that?
Yeah.
Yeah. Back in May, right?
Back in May, yeah.
Yeah, yeah, because it was, yeah, it seemed interesting, more than a game, right?
Yeah, and I found a couple of links on YouTube clips that go into more detail. I'll post it as a follow-up to your thread. But again, just a hint at what the future might look like to apply these. It gets me very excited. The other one is, and this guy, I'm not sure, I don't want to call him a crackpot. I don't, because the guy's super smart. I don't know if he's going the right direction or not, but we have all lived through a series of discussions of cognitive frameworks, right? Pie in the sky, hand wavy. When we craft artificial intelligence, even 20, 40 years ago, here are all the pieces that it should have. This guy has created a theory of cognition that is based around the capabilities and framework of the large language models of today. And he's released a couple of video clips. His first one that talks about the framework, and his last one where he has set up a small team of people to work on the different concepts practically, I'm wrapping my head around and I still don't quite understand, which just means I don't understand. But this guy's trying to crack general intelligence using the tools available now. And whether he succeeds or not, we're going to learn a lot about how to approach AGI, I think, from his work as well. So he calls it the ACE framework. There's YouTube clips and a GitHub that Dennis kind enough to post on there. Something that I'm tracking just to see what he makes of it. An applied cognitive framework based on Langchain and ROS. All right. Okay, now for the fun stuff. So with all that as a background, I'm excited about this. This seems like a way to make large language models useful. A taste of how you can use a large language model to do something. Hopefully gives you the background for what we're going to talk about for the next hour or so. Langchain is a framework and a set of tools to implement what I'm calling directive cognition with a large language model. Meaning you're setting up, using the framework to set up a scenario in which the large language model can solve a problem or answer a question in a useful manner. There are a couple of ways of breaking down what how this all fits together. I like to break it down into a series of 3 concepts. The first one is the prompt, right? And we've already ran into that. When you're running it as a chatbot, your prompt is just whatever you enter it. Hey, how you doing? How many quarks are there, and what are their things? In casual conversation, it doesn't really matter. But there's a lot of work and research that's gone into how to phrase questions and scenarios in a way that gives the large language model an opportunity to respond in a way that's useful, right? And sometimes it's the phrasing. Sometimes the large language is smart enough that you can just ask it the question in what's called a 0 shot, and it's able to respond in a manner that's useful. Other times, you may want to set it up with a couple of examples. I'm going to show you exactly how that works in a couple of different ways in a few minutes, so that when you pose the question, the large language model understands the type of a response that you're doing. So a lot of the work in Langchain goes into creating a prompt to elicit the response that you need. And there's a whole bunch of tools to make that happen. The next one is they're calling a chain. And so when you take a prompt and some Python code in a situation, and this one I might not be getting exactly right, but the definition will work anyways. You can wrap that prompt and the Python logic and even a piece at the end to pull the information out of the response into a tool called a chain. And so our hello world, in a few minutes, we're going to deep dive into a chain called the LLM math chain. And what that chain does is you provided a math problem in English, and it translates that math problem into something that you would write into a calculator. And then it solves that math problem using Python number expression, right? And so, prompts set up the LLM for success, and then that prompt takes your input and combines it with some Python code to do something into a concept called a chain. And finally, the best part, the fun part, is called an agent. So an agent takes those prompts and those chains as a series of tools and understands how to leverage those tools to get point A to point B. So what I posted about the who is the current president of the United States and how old are they? That's an example of a chain that's using the Wikipedia lookup tool, that's using the DuckDuckGo search tool, that's using the LLM math tool, and tying them all together to be able to answer that question, which it just blows my mind. Even it's a contrived example, but watching it go through the steps to get a real answer without hallucinating is just amazing. So here are some of the approaches. Sorry, I'm taking one quickly. Sorry. Going back to here. And there's papers that back all of this up, but I don't think we need to pull those up. So these are different techniques, different ways of applying this to get information, better results out of it. And the first one was called RAG, Retrieval Augmented Generation. And so what that means is setting up a series of tools to stuff information into the prompt so that the prompt has enough information to factually answer. So, and so there's a whole, and we're going to get into like the embeddings in the database and all that stuff. But even for like a Wikipedia search, right? So if you have this set up so that when you answer a question, there's a piece of code that looks at your question and bounces it off of Wikipedia for an answer, and then takes that snippet and pastes it into the prompt, that's RAG. That's retrieval augmented generation. If you've taken a technical paper and you have broken it down into sections and stored its embeddings in a database, and then you query that database to pull the relevant sections of that paper out to answer the question, that's also RAG, retrieval augmented generation, which is kind of our, after we go through LLM math chain, we'll show you this piece, because a lot of what we're doing afterwards, this is like, in my opinion, the crown jewel, giving it tools to go out and grab stuff to provide the needed context to solve the problem and answer the question. And I think I have these in chronological order, although this has all happened within the past like half year or so, who knows. React stands for reasoning and acting, which is an approach that breaks down a problem into smaller problems and then solves each of those smaller problems to come up with a solution. So getting back to that, how old is the current president, what is their age? That's a React agent. It looks at the problem, it figures out in order to pardon me, answer this. I need to find the current president, so it does that, and we'll try that live towards the end again. And then to find their age, and then to find the current year, and then to do math to figure out that he's 80. The last two, chain of thoughts and tree of thoughts, they figured out a few months ago that on a fine-tuned model, if you ask it a question and get an answer, sometimes the answer is wrong and it hallucinates. And you can do this over a standard set of questions and then figure out the percentage of right versus wrong answers. What they found was simply asking the LLM to show its reasoning and fine-tuning that language model with hundreds and thousands of examples of showing its reasoning resulted in a dramatic increase in truthfulness in answers, just by showing it examples of how to ask it, and then asking it a way that it shows its reason. Just making it show its work resulted in more accurate answers. That's just amazing. And the last one, very recently, is a variation of that called tree of thoughts. You can think of it as a mixture of chain of thoughts and reasoning and acting, in that it comes up with a game plan, it explores that game plan, and it evaluates the results of each step of that game plan, and if one of those results in a false, it'll go back up that tree and try something else. And that concept adaptation is cutting edge right now. I don't think there's anything in Langchain to support that, but these are the main areas that you can think of it as a design pattern, I guess, of using the LLM to do something interesting. Okay, wow, all right, I'm actually back on time. All right, now, good news, bad news, we're gonna do a deep dive at the end of this second hour. I believe you're gonna be in a good position to hit the ground running and to use these tools to do interesting things with robotics and artificial intelligence. The bad news is that it's gonna be all code, something that I don't normally do, but I've broken it down in Jupyter, so it's a bite-sized, it's a bite-sized approach. And again, I apologize, but there's no way to go through what we need to do next by slides and pretty pictures.
I love code.
And so there was a short thread that we had done a few. I think it's some maybe it's
one small question about that last section is, is it similar to the OpenAI's function capability now? Is another way to kind of, it's like a more primitive way to do that, to do the extraction you're talking about, or the to do the RAG. RAG is a better way, a more sophisticated way than what we have at our fingertips now is that those function capability in OpenAI which can call functions based on things, and it's similar, related, is it related?
Yeah.
It's related?
Yeah, and I haven't I haven't delved myself into OpenAI and ChatGPT functions, but the idea is the same, right? A set of tools to stuff enough relative information into the prompt so that the LLM can give you a truthful answer.
I think those functions are RAG, it's just a syntax.
It's
of
okay,
doing
it is,
that
yeah,
that
that's
task.
what I was trying to understand.
Yeah, and so not to belabor the point too much, but what started out as a half-handed comment to Ben a few weeks ago, I
Yes.
am 100% on board. Using Jupyter in VSCode to write Python is amazing. And if I were to rewrite this, I would probably add on a fifth one. I am paying for Copilot for a couple of months to see how useful it is. And so there might be one above this with using Python in a Jupyter notebook in VSCode and with Copilot as your Copilot. Back over there. Okay, so our general introduction to the OpenAI API. This is using a tool called Langchain. So, before we even get there, if you're doing this, you are of course setting this up in an Anaconda environment, right? So you're not dealing with DLL, so you have an Anaconda environment set up just for Langchain, and you've done a pip install Langchain and pip install OpenAPI to make the tools available. From within the notebook, you can select the right Conda environment, and so we're going to import those two tools. And here is where we tell it to use my own personal endpoint and not to use OpenAPI. So OpenAPI is the wrapper. By default, you pass it your private key. Don't worry, this is not my private key. And then it, from that point forward, any calls to OpenAPI or Chat OpenAPI gets bounced off of their servers. By specifying your own endpoint, which is something that you see. Okay, it's already towards the top now. Go ahead and refresh this. When you first launch it, it'll give you the endpoint. You just put in your own computer's IP address here. And so we'll pass that in. If you ever want to bounce, if you have an account and want to bounce it out, all you need to do is exit out of there and put in your own API key, and then you can compare and contrast. But we're going to run it locally because I think that's just awesome. So I'll run that in. And what's funny is my simple example here doesn't work. It doesn't provide enough context for Mistral. So it'll be a blank, but as a sample one, you can just pass it a quick series of text. Let's just try it one more time. Just to make sure that everything works. And it's going to give something random because it doesn't have enough context to provide a meaningful response, but it works. And if we go back over to our search here, it's just sending out a whole bunch of stuff.
Oh, it's just
but that is.
Is that a log there? Or?
Yeah, something.
Debug log?
So that's the trick. You've got an OpenAPI object. And so everything I'm showing you here is also on their website. Their website is very thorough and has a lot of simple examples and ones that give a starting point, which is nice. There's a lot of projects out there that don't put as much effort into their documentation. This documentation is pretty solid. But getting back over to the code now. So that's our setup. We can define an OpenAI model that points to our local endpoint, which we're running in the background, and we can run a simple query. So far, so good. So I mentioned that there were, the way I'm looking at it, there are three different pieces to make all this work. The first one is prompt templates. And so they have a series of functions and objects that you can use to simplify the using prompts to do interesting things. So let's go ahead and import that. All right. So I've got an example of a prompt here. Let me go and grab it really quick. So I'll tell you where I got this in a second. For now, I'm just going to use it.
Did you write, is this your workbook? I mean, you wrote this particular?
Oh, the workbook? Yeah.
Because I haven't written my own. It's pretty easy to write your own. Yeah.
Oh,
Is it more? Yeah. You use them a lot.
yeah, maybe you know what? Maybe I'll do that as a quick show and tell after lunch. It's yeah, I'm 100% on board with this way of
Yeah, I really like.
I'll add you to the list. All right. All right, so let's go ahead and refresh. And so what I'm going to do is I'm going to use the notebook tab to set up a hypothetical. And so what we're looking at here is actually almost the default prompt from LLM Mathchain, the Langchain chain that can solve simple math problems. And in this prompt, and this is exactly what's being cast, translate a math problem into something that can be evaluated by Python's expression library. And then we give it a couple of examples. So this is an example of few-shot or multi-shot, where you're going to give them an opportunity to answer correctly by providing examples of what a correct answer looks like. And so you've got this template here that describes what should be in the result, and then a couple of examples. So question number one, what is this number times this one? It breaks it out into text, and then it shows you what the number evaluate string should look like. Option number two, what is 37,593 to the power of 1/5? It formats it into a numeric expression compatible text, and then shows you what the evaluation looks like. And then it ends up with the question. So this placeholder, we'll see again in a few minutes. Let's try it to see how it works out.
Interesting, the triple quote, that's very Python.
Yeah, and there's a couple of reasons for that I'll show you in a few minutes. But so we've got what we want, we've got a couple of examples. Let's ask it a question. What's 8 to the power of 8? And it goes on past that. No, that's okay, we didn't set up the right stop character. But looking down, what's 8 to the power of 8? Here's the text. That's the way the format is, and that's the way numeric evaluate works.
So that's as far as you expect this to go, to get
Yeah.
the, and then that that would be passed to Python.
Yep. What's 8 squared minus 1? So we'll use a mixture of numbers and there. Stop it, and what's 8 squared minus 1? Literal 8 minus 1. So we don't have any PEMDAS parentheses to enforce it. So we're assuming PEMDAS rules, which is a little bit of a challenge, and it just does it, right? So this seems useful. So we have an example of a prompt to answer a specific type of question. We give it a couple of examples, and then we set it up so that the output can be grabbed and to be done something with. The prompt you're looking at is the exact prompt that is used in LLM Mathchain. That chain that you get out of the box to get answers to math problems. So I'm sure we've all tried it from ChatGPT and others. ChatGPT is better. I think I know why. But it doesn't really do math, but it knows what math looks like. So occasionally it'll get the right answer, and oftentimes it'll confidently give you a. And this elegantly solves this problem. So let's go back over to
And why was it even continuing with total other stuff? That's just
Yeah, in the,
kind of,
in text generation UI, I don't have the right, stop token set up,
Yeah.
so it lets.
so it's continuing on other
Yeah,
related,
just on
math.
just on that screen, it's hallucinating everything that happens after it. Yeah,
It's no problem.
I could go in and add in the right,
So if you have a
stop
stop thing, then that's
Yeah,
not an issue.
And so here you see the Langchain way of handling that. And the Langchain prompt template accepts two items. The text of the prompt that we just used with a placeholder, like an F string almost, for question. And then the input variable, which matches the tag for that F string question as well. And so that is how they wrap up templates. That is a Langchain prompt right there. And you can have multiple input variables, and I suspect multiple output variables. So what we'll do is we'll define that math prompt, the one that we already just played with. And same as before, we'll define an open API object using my own endpoint. And what we can do is we can so in the prompt, we can provide what the question is, and then the result is it emits the text of what that prompt should be. So all of our boilerplate text for the context, the multi-shot, and at the very end, it plops in things. Yeah. So that way you can bake all of that context into the prompt and not have to worry about copying and pasting it for each one. All right. So for the next step in that, here we have so my prompt format, and then we can bounce that off of that resulting prompt off of your LLM using fast LLM predict, which we defined up here. And you get the same thing as we did over in text generation web UI. So there's the first one, 8 to the power of 2 times 10, and the number expression evaluate with that as a string, and it's right. So you can use words for numbers, numbers for numbers, and then you can use the large language model to translate that into a format that we can use and evaluate. All right. You guys are troopers. So far, so good. All right, so let's use LLM Math Chain as our Langchain 101. Let's pull this apart and see exactly how it works. I think that'll be really useful to understanding how to really use these things. It's a really, really simple simple chain. So we'll go over to our new notebook. We'll use code activate Langchain. Let's bring in the required objects. Just a moment, there we go. And then there are some optional things that you can set that make the output a lot more verbose, especially if you're troubleshooting. You can set these to true. And it shows you every step of the way, the input and the output for. I'll leave them commented out for All right, so here's we have defined my fast LLM. My large LLM I don't even use anymore, so we'll just take that out. Just as we did before, so this is the OpenAI object that points to our local OpenAI endpoint. Here is our description of the prompt template that we want to use, right? We already did that on the last screen. The way you pull it out of the box is you'll see it one way. If you're anything like me, I like to look at it in normal English, so I'll triple quote the template and I'll break everything out so it's easier for me to see. They are functionally equivalent. It's just harder for me to see and read and intuit about the all one line versus here. And so what we'll do here is we'll define a math chain called LLM math, and it's using our pulled in LLM math chain object. We're passing our open API object, so it knows what to bounce the queries off of. We're passing our prompt, even though this step is optional. It has the prompt already in it, but I prefer doing it this way so that I can make changes to the prompt, because the fact of the matter is that everyone who developed Langchain developed this against OpenAI, ChatGPT, and GPT-4. I'm using it against a local model, so there's a very real chance that the prompts that I need to use need to be a little bit different than the other model. So I'll always take this extra step of grabbing what their prompt is and then spelling it out, just in case I run into anything weird, so that I can customize it so it works better in this exact scenario. Although, to be honest, I haven't had to do that yet, but I want to leave the option open, so this is why I defined it. And then verbose equals true, tell me a little bit more about how things are.
I mean, you're overriding there. If you just said LL, just by using that math chain, you're getting the same, you're getting a prompt in there.
Yeah.
You're able to override and modify.
Exactly. If I left this out, it would still run just fine.
It's using the
just like this.
one. In fact, it's using the one.
Yeah, but I'm gonna attach it to my prompt just to give you the flexibility. It's a habit that I built in for myself, because I know that at some point I'm gonna run into problems because I'm using a different model, and I want the flexibility to customize the prompt to get it to work. Let's go ahead and run that. All right, and so the running semantics are a little bit different. The LLM math object has a run method. When you say run, it passes, you pass what the input is, that input is then pasted into the S string for the prompt, it bounces off of the LLM, and you get an answer. So here, let's do this. Let's turn verbose equals true to this a little bit more. And we'll see what the difference is. Operation show your work. All right, so our question was, okay, what is 8 to the power of 4 divided by 2 plus 1? 8 to the power of 4 divided by 2 plus 1, PEMDAS rules. So they didn't see any reason to disambiguate that, which is okay. Expression evaluate, and I'm not going to pull up my calculator, but it's got the right answer. And so we can run any one of these. And what this does is there's no opportunity to hallucinate. Every once in a while, it'll send an incorrect prompt, like it'll try to send a date time function. But 90% of the time, it does what it says on the tin. Take the word problem, convert it into a math problem, bounce it off of notes versus evaluate, and you get the answer.
And that last part though is in the run, where it actually takes the expression and puts it through Python.
Yeah, and so just to double check our math, I went ahead and imported number expression, and we'll do a number expression evaluate. And we get a single element array, 2049.
So Alec,
Nice.
I see it generated all the text. Who called the evaluate function? Like, how did that happen?
That's what I was just asking.
Yeah.
I think isn't that in the run, math.run?
Yeah, exactly. So we declare an LLM math chain object, and we pass in the OpenAI object that we defined up here that tells it how to run and get an answer. And we pass it the prompt that we defined up here. And we'll say verbose equals to true. And so that LLM math chain object has a run method. And the run method takes a string input, and then it uses the prompt to generate the prompt object to generate a prompt that's passed to my fast LLM. And then there's an output parser that grabs the important part of this and runs it off of the number expression. So
okay, that'd be specific to that tool, that output parser. We look for that, and they'll call the Python for that.
Yeah. So here, let's take a look.
So there's an output parser, right? We're part of that run thing.
Yeah. So what we're looking at right now is the source code to the LLM math chain object. And I'm not going to drain the whole slide because you get right now like how it works. It takes the prompt, it runs it off, it parses the output, and then it runs number expression to do that. So here we can see that it pulls in the default prompt from LangChain's LLM math prompt. And that's a default. We're overriding it with the same thing, but I want that flexibility. There's an input key for question, an output key for answer. This input key question needs to match the prompt template that we sent. And then there's an input and output keys validator on it. And so I'm reading this out of order, sorry. Evaluate expression, process LLM result. There's a run in here somewhere. There's a call. There we go. What was that? So yeah, so there's an asynchronous and a synchronous call. Reading between the lines, it takes that prompt, it bounces it off of the LLM. When it gets a result back, it does a little bit of wizardry. Notice we've got a search prompt with a contextual feature. Remember that formatting you were talking about, Jim, with the three quotes? That is how it's pulling out the result.
So it like,
Yeah, so is it perfect? No. Is there a possibility that the LLM could generate output without those and cause an error? Absolutely. It's non-deterministic. We'll just set it up for success, and it's up to us to make it as simple as possible. And I haven't read through the code, but I would expect or would want that if it is processing a result without these characteristics, that it tries again. Or if it, in addition, if it tries to run the results of it and it gets an error, to try again as well, right? Your code's going to be brittle. It's the LLM that's flexible, and sometimes that flexibility can bite you in the tuchus.
Yes, this is fascinating because it's still a textual interaction, input and output, and we're just adding parsers, and we're basically adding code to evaluate the output and extract. So it's almost like this entity looking at a conversation going between you and the LLM. Hey,
Yeah,
so
exactly.
It's fascinating because that could, it's a little brittle.
Yeah, it can be, and that's probably one of the biggest dangers. And you'll see that even when using the agents of Langchain, occasionally the language model spits out something that you can't use. And so that's where your directed cognition needs to be able to handle that, right? But yeah, so as a hello world example, the LLM math chain is perfect. You can see the prompt and how it works, when it feeds into the LLM, and then when it gets the information back out, how it parses out what the answer, and then it just evaluates it. It just evaluates the response and it gives you the answer. And with this one tool, your large language model can do that, right? Reliably, yeah.
Yeah, well, it's interesting how this differs from, remember when I presented a talk about just the engineering, prompt engineering, there was a way to, the earlier ways were to tell it to do it, to give examples of math and then say, show your work, and then it would do better than before. Yeah. Whereas this is a more like, we're like really kind of locking in the best we can do as far as we're not going to rely on the language model, no matter, it's only by itself.
Yeah. So, yeah, and it's a great encapsulation of the spirit of and the power of Langchain, is wrapping procedural text-directed cognition around the generational AI to get it to do something useful. So I'm going to skip around a little bit in the interest of time, because this next one is super important. And that is the concept of databases, embeddings, and how to store stuff in a way that you can get that information back out, right? Because, and this is RAG, right? Augmented generation. And to not to get too far ahead of myself, but this feels a lot like memory. And I simplified the approach last week when I was thinking about how to show you how all this works and fits together. But the crux of it is what's called a vector database, which is a database you can use to store stuff, and the concept of embeddings or vector embeddings. Now, we're all familiar with simple search, right? So Mary had a little lamb, a keyword search for does this have the word lamb in it? Whether it's case sensitive or not, is it uppercase Mary or lowercase L lamb? The concept of searching for a substring and a string is something that we've all done. The vector embeddings kicks it up a notch by embedding the context of the words instead of just the words. And the best diagram I found to explain this was I grabbed off of a screenshot for a YouTube clip. If you wanted to imagine your vector space as an XY grid, XY value, two numbers, from 0 to 1 or 0 to 100 or whatever, and you started dropping words into that XY feature space, that Cartesian plane, the words for puppy, dog, and wolf would probably be grouped in roughly the same spot, right, based on their semantic relationship to each other. Whereas coffee, tea, and milk would be grouped in a different area, right? So they're all beverages, they're things that you drink, you call them healthy. So in an XY grid, they would be grouped in a different spot. And so that coordinate, if you had a coordinate more over on 75, 75, that would suggest that what you're talking about is more in the dog, wolf, puppy category. And if it was something like 25 or 0.25, that would be more in the beverage, coffee, tea category. That's the power of embeddings, is that and it's backed off of a large language model, or a language model itself, is you take a bit of text, you run it through the embeddings engine, and it generates a 124 or 5000 or 768 element embedding that describes semantically where the different concepts lie on this multidimensional grid. So it's a multi-dimensional. This visual just kind of gives you a feel for it. It's a step above keyword search, and it is what the vector databases are based on. Because once you take a bit of text and you run it through your embeddings function, and you get the embeddings for that text, you can then store the embeddings and the text in a database like ChromaDB, or like Pinecone was the first. It's online, it's a paid thing. ChromaDB is free open source, you can run it locally. And then you can run semantic similarity searches off of that embedding to get the documents that relate to your question, your subject, right? Super cool, right? You're using you're using AI to code text and then using AI to figure out where it's at. So I have a more complicated example, but I really like this one because it drives home that the search and retrieval is contextual. It's not based on simply the words. So we'll pull in a retrieval QA, we'll pull in the Chroma database, if installed, if we don't already have it. And I appropriated and extended this based on something I found online. Let's have a couple of really simple documents, apples and bananas, but there's two different contexts for apples. The apples that you eat and the apple that is the company, right? So in a simple keyword search, tell me everything with the word apple in it, it would pull almost all of these, right? But if you had a way of creating a semantic embedding that conceptually separates those two contexts because they're concept, that makes your vector database a lot more useful. So this is the linchpin for local document retrieval and storage for, again, for RAG. The whole purpose being get the right information in front of the language model so the language model can answer your question more accurately. So check this out. I've got a couple of examples. All right. So in order to do this, you have to have an embedding model and an embedding function. So one that Chroma DB recommends out of the box is all mini LMV 6v2. It's very, very small and very, very fast. It turns out, well, OpenAI of course offers their own embedding function through their OpenAI API. They charge you for it, but it turns out that their embedding model isn't state of the art anymore. Going with Alan's, there's a web page for everything. There is a web page for embeddings leaderboard.
Wow.
And if you look, the text embedding 892, which is the standard embedding for OpenAI, is in 14th place. And again, these aren't bad, they're just different shades of awesome. And the mini LM is somewhere below that. But top of the leaderboard right now are VGE base and large. I'm gonna go with VGE base. It's small, it's fast, and so whichever one you select, you've got to kind of stick with. You can't embed a whole bunch of documents with one model and then decide to change your mind later and use the embeddings on your question later on. So and just like large language model, there's a lot of exciting activity in this space. I'll probably end up playing around with both. My gut's telling me that 1024 embedding dimensions will be a little bit more nuanced than a 768. And the embedding function, there's only a cost when you embed the document. So once they're embedded, it's just the cost of embedding your question or your query. So I'll probably play with the large as well. But getting back to our example, we'll call it the way you need to, the AI-based VGE. If you don't have the model already downloaded, it'll download it for you. The sentence transformer embeddings is nice like that. And so our first one, quick doc search, is Apple a big company? And it responds with the first 4 results. They'll repeat if there's nothing else. And we had one that was responsive 100%, so that's the only one we got back. So it's semantic embeddings in search allows you to get contextually more relevant information than just a keyword search. So let's try the second one. What is the name for the study of apples? And so here we have right here, the science of apple growing is called pomology. I didn't call it the study of. So really the only word the responsive document has in common with the question I'm asking it is apple. So in a traditional keyword search, this would be tricky. And because of this, solely by virtue of the semantic embeddings, it finds the right document that's responsive to the question. This, again, seems useful.
Very useful.
They both have growing, so did that help it?
Perhaps, yeah.
Oh, no, it does. Oh,
No,
I
it
see.
doesn't have
No, it
growing.
doesn't have growing. Oh, okay, so the answer only had growing, not the question. Okay.
Right, so when you're talking about one of the fundamental concepts and tools to get your robot smart and to store, to have, I'm gonna go a step further, let's add some mice for it. I'm gonna call it memories. To be able to take in documents and web pages, to be able to store them in a way to retrieve the relevant documents as part of a conversation. And thinking back a little bit further, to take the paper and then summarize it to make it easier to find. These all seem like really great building blocks to do something really interesting. Yeah.
Could you, I mean, we all probably remember, the language of Prolog that has been talked about as memory. The old school AI from the 80s, really, or even, well, probably before then, but Prolog, you had statements, you had a series of statements of fact and whatever, and relationships, logical relationships and all that. That's the old school way. So I'm wondering, this seems like a great new way to do that. As long as you could, as your robot's moving along, say, it gains new memories, or it sees things, you would want to embed that right then into the database. Is that something reasonable to do, like computationally to add, as opposed to having an original document? So I'm just going to append and add appended embeddings. Does that work, or do I have to keep that?
Yeah, if I'm following you, there could be workflows in your, let's just call it in your AI, in your assistant, where it is able to intake and create embeddings and store new information over the course of the conversation. Same thing for logs. So when you're doing an AI, like, you want it to keep the rest of the conversation, right? So, and how you store that, your store could be a simple database. Like, I want things like the time and the date, what was said, what was the context for the response, right? You could store all of those in a traditional database. You could then index them using your Chrome DB embeddings to make them easier to retrieve, right? This whole thing just reeks of memory, like anthropomorphized memory.
You just have to when you add a new memory to the database, then you have to embed it. You have to
Then you
compute
embed
the
it, and then it makes it available as part of the embedding function. So you could have different buckets for different things, like knowledge, conversation, memories, past conversations, and then it's in your directed cognition in your code that you decide which bucket you run the queries off of, depending on what you're trying to do.
Okay, yeah, there's different.
Sorry, I'm using my excited voice right now, but yeah, this is.
You've got two different things, yeah, the one you did before there, the content, and then this is the new memory as well as the, what did you call it, the previous stuff you were working on with as well. Sorry, my voice.
But if you took pictures from your robot and you could do image to text, this would be a great way to find those images, because it might say this is a cat, and it might say it's a kitten, but this will find it. But putting those two together would be really, really.
Yeah, and
Well,
I
you
get
have that.
far ahead of myself is if I have a slot next month, that's exactly what I'm talking about. The lava thing that I posted about is getting me very. I just bought an OP camera to
Nice.
really drive it home with 3-dimensional localization, and then calling out that box and then sending that bit of a picture to lava to characterize, and then using object persistence, some type of filtering. Like, it seems like there could be a lot of machine work to be done there. Yeah.
Well, then,
Yeah, I agree. I said I agree, that's really great. And then you could put it on top of the time, and if you know the location, so this was in the kitchen, and you could put all that together and have a lot of, and wrapping and embedding to make it really usable.
So you can say, where are my keys? And it could look for keys in pictures and find the keys, and then say the keys are next to the toaster or something.
Yeah.
And then you know where that is, something like that. Or you could give some relative information. That's really neat.
Yeah, and so to wrap up this document retrieval concept as a tool, we need to make it into a chain. The chain is the intermediate step that then makes it available to agents to do things with. And the boilerplate code for that is first, we'll define our LLM again, OpenAI, local. And the format for that is we'll define a QA chain, and it's using the retrieval from QA chain object, from chain type method. Here's the LLM I want to use. Here's the technique that I want to use to traverse, to interrogate the Chroma database. And then here's the Chroma database we defined up ahead, doc search, which is this guy right here. So it's all boilerplate and it's available on the website. But then once you have that in place as a chain, your agents can make use of that. And so when you bolt it together like that, so we define a query string object, and then to bounce that off of the chain, you pass the query to the chain, and then we should get something similar.
What were you doing before? It wasn't the chain. It was not the chain. It was...
Yep. So this incorporates it with, and we'll take a peek back over our large language model to see if it used it. Yep. Okay. So in the chain uses the large language model to filter and format the output. So the retriever from QA chain it bounces the query off of our Chroma database doc retriever, which you can see here.
That's the doc, that's the retrieval.
Yeah, so here, what is the name for the study of apples? Here is the result that we already saw from the Chroma DB retrieve operation. There was only one document that was responsive, so it appears 4 times because it sends max 4, only 4. And then based on that input, it crafts a final answer, which is hidden in here somewhere. So the generated response based on the prompt, the name for the study of apples is belongs.
I see, before you were getting the raw output.
The raw output just from the doc
language.
retriever.
From the doc retriever.
Yeah.
And then now you're running it through Langchain, which is adding it's doing the entire end-to-end.
The end-to-end answering the question. Yeah, it's using the LLM as a tool in the retriever QA tool chain to answer the question based on the top 4 relevant docs retrieved from the Chroma database where your question was encoded as an embedding, and then it uses an embedding search to find the most relevant doc.
So it's from there of course the Langchain can send to all, like I think you were saying, to different directions to where you want to go, whereas when you were just trying the retrieval, that's just using a single doc. You could get the answer using that alone if you want, if you're just doing this type of thing.
Yeah.
But yeah, this brings in Langchain brings in so much flexibility.
Yeah, using the large language model to distill the answer to a question from ChromaDB as a chain in a higher level agent. I think that's where we're going to end up today based on time. And so let me move over to Intro to Tools and Agents. So this is, and I haven't looked through the source code for the agent that they use. The agent that we're defining here is a React agent. So reason in React, it breaks down the problem into smaller questions, and then it solves each smaller question and then derives the answer from there. So this is, to wrap up our talk today, let me show you how you set up that agent using some of the tools we've already talked about to do interesting stuff. So again, we have a new notebook. We'll make sure that we're selecting the my Langchain conda environment. We'll pull in a whole bunch of modules. And then by now this should seem familiar. We are defining the OpenAI object to point at my local my local generation. And then we're going to define a couple of new ones. There's a wrapper for the Wikipedia API that is that's like a Wikipedia search chain. So let's initialize that. We'll do a quick one. Do a Wikipedia search for the Declaration of Independence. And so it pulls back a portion of the search result for that just to make sure that it works. We'll set up DuckDuckGo as a search engine. I want to use Google, but Google requires you to set yourself up with an API key, and I just wasn't smart enough to figure it out. So we'll use DuckDuckGo for our search engine for now.
Yeah, Google makes it a little bit.
And when running this query as a DuckDuck search, we get a document back just to make sure it works. And let's also set up that LLM math chain here. So this seems like it would be useful. And a quick test, we'll run a sample, and then it does it, so we know we're running there.
It's a fractional answer.
Yeah. And that was 8 to the power of 4 divided by 2 plus 1.
Division.
Oh, and notice in that case, it enforced the PEMDAS parentheses to disambiguate the result. That's nice.
You call it PEMDAS?
PEMDAS, right?
The
PEMDAS.
What is that?
Initiation, application,
You put parentheses, then exponents, then multiplication, then division.
Oh, okay, that's an acronym, yeah.
Yeah.
It's like the rule, I'm just such a C programmer, I think of it as the C rules of order.
Am I pronouncing it wrong? Is it PEMDAS?
No, that's right.
PEMDAS?
PEMDAS.
multiply PEMDAS.
Please excuse me,
Or
dear
please,
Aunt
it sounds
Sally.
like Deer and Sally.
I never really learned that name growing up.
I only memorized it, I never, an acronym, boy.
Parentheses, exponent, yeah, it's just similar to C.
Next thing you know, you'll be teaching me how to spell arithmetic around the house.
So the next step is we're going to set up these tools into an array in a way that your Langchain expert expects to see them. And this step itself is also very cool. And when you're setting up a tool has 3 components. The first one is the name. And the name is part of the description in the LLM prompt that tells the prompt how to call the function. So there's a part where it says, if you need to do a search, you will call a tool, and the name of the tool you'll call a search. You'll pass it the function that you want to call when you're using that tool. And I think most exciting, the description tells it tells the generative AI the circumstances under which you need to run the tool. So you'll run search when you need to answer questions about current events. You'll run Wikipedia when you need to answer questions about general knowledge. And you'll run calculator when you want to answer questions about math. And so that's how you're wiring it together. You're passing these tools and you're telling the agent how to call them and when to use them. I'm just stunned. That's like the coolest thing since sliced bread. So we'll set up the toolkit with 3 different tools: search, Wikipedia, and calculator. And there are a lot of other examples. And you can define your own tools. So there's a lot more, if you want it to be able to manage your calendar, there's probably already a tool for that. And for your own custom tools, the one you pull in, what to call it, how to call it, and when to call it.
You wanna make a whole lot of money, take this, put a gooey wrapper around it, and start selling it, and start a business.
That's what they're doing. Yeah, everyone and their kid brother is spooling off an AI company with some sweet VC funds, and a lot of them are they find something new to do. But now when you see the advertised YouTube clips, when you're looking at what they're offering, know in the background, this is the exact toolkit, this is the framework that they're using to get from A to point B. And now that we've seen how memory works and how leveraging directed cognition, and that example with Stardew Valley, right? There's a possible future where you can tie these together and do some really interesting stuff.
So were you saying that him running that Stardew Valley thing we were talking about today?
Yeah, because all of his queries are being run off of either GPT-4 or ChatGPT. And he has one with 16 characters. And so each character, each step is a run with context and there.
So I might.
Wait, this is,
You could if you run it locally.
Oh, got it.
was this a YouTube, or is this the guy you're talking about?
Yeah, I'll
Does he
post
have
a couple of YouTube clips and some
something-
follow-up videos to your thread. But yeah, where he walks through how it works and the code's available, you can download it. I tried to run it locally and I was less successful. And I spent more time seeing his setup, and he didn't use Langchain, so he hand-coded all of
it
these
was not
things
Langchain, yeah.
no. But and for a split second, I was thinking it'd be fun to rewrite it in Langchain, but there is a lot of code there. I got all someone else do it.
But it's a good example. I mean, his example.
Yeah,
is
it's
a good
an
thing to
idea of
look
what
at.
a self-motivating agent would look like,
Yeah.
right? I mean, Sims is kind of the same way. You have the code for this one, but when you look into it, they've got a backstory and motivations, and they have their conversational history, and they have a way of condensing that to fit it into the prompt to be able to move forward. And there was a bunch of examples of cooperative emergent behavior, and whether they were handpicked or not, it's really cool, visually very exciting. All right, so we have our tools defined. We'll initialize our agent. And again, this is all boilerplate. There's examples on the website. The initialized agent function accepts a couple of parameters. We'll pass our toolkit, our tool chain, our list of 3 tools. We'll pass our OpenAI object, our past LLM. The agent that we're using for this is zero-shot React description. I don't know why it's called that, but that's an example of a React agent that's out of the box. And we'll set verbose equals to true so we can see how it works things out. If this is omitted, it would just give you an answer. What's the fun of that? So for our first one, let's ask it a quick question. What is Langchain? Oh, you know what? Here, let me go ahead and run this cell before. I didn't run them, I just talked about them. Sorry, I was getting too excited.
Control enter, right? Did you know that control enter?
There we go. Oh, it runs them all? Yeah.
Or it runs each one.
Many tools for hardware interface, controlling servo motors.
You would do that by running your own chain, yeah. So you could write a chain that does something based on the logic that you specify in the prompt.
So there's nothing.
Nothing in there, yeah. So this is outside of all of
New
the.
business.
Yeah, yeah. Yeah, there's
I'll be
actually
writing
been a
that.
fair bit of work on applying neural networks to coordination tasks. Yeah, whole different area, but still very exciting, yeah. All right, so let's go ahead and run it.
It wouldn't be that hard, I mean, if you understand all this stuff, I think writing a driver for the, for the servo is just a step that we are capable of, I
If
think.
you just talk to an Arduino or.
I would just mean that the last piece of code needed in all this to do that is definitely doable by people like us. I mean,
Yeah.
That should be trivial.
Yeah, this puts it firmly in our hands. There is definitely the possibility of doing interesting things using this toolkit. Yeah, where I've just been psyched as all get out. All right, so our question was, what is Langchain? It goes through, it kind of knew what it was because Mistral is a more recent model.
Yeah.
It knows that it needs to search, and then it does a search and it gets the results. And then it's like, now that I know what Langchain is, let's find out how it works. And it wants to bounce it off of Wikipedia. It gets a snippet from Wikipedia, and then it's like, let's see how it's used. Bounces another query off of Wikipedia. And it gets final answer. Langchain is a framework that is designed to simplify the creation. Just wow.
Well, wait, there's a few things going on here in that agent, though, that's doing the asking. So is that in this new agent that's asking additional questions and then somehow summarizing the final?
Yep, it's an example of a React agent.
That's React.
Mhm.
Oh, okay, so that's a whole sort of study or whatever.
Yeah, and I haven't looked into the source on that, but just wow.
But I mean, it's a usable thing. I mean, basically
Yeah, out of the box.
And it's using the three, well, in this case, it didn't use the calculator probably, obviously, in this question, but it knew to use the Wikipedia one. And
yeah, based on our toolkit, we told it to use the Wikipedia tool when we were looking at facts.
right, so this is like a whole hour of, I mean, there's a deep dive, a lot of information, just this React thing.
Yeah. Yeah, for sure. Let's run a few more off, and then we'll,
And you misspelled it on purpose.
yes.
I don't know the current president, so I will search it up.
And it got it wrong.
No, yeah, I got it wrong.
Interesting.
What does current mean? Does current translate to September?
Tool in search.
It's using DuckDuckGo.
Oh, now it got Joe Biden.
And it got it right. So like even when it gets it wrong, like enabling debugging and trace down like where it went wrong, like this is a rich opportunity to dig in and probably this weekend after Caterwall, and I'll dig into the code for the React agent to see how it works.
It's probably, since it did a search, it's probably,
The search result that it
there's a
found.
The thing is,
lot
when
of misinformation, so it might have
Well, I think it was stale because
It
it
may
doesn't,
have just been the link that it
it
selected.
just, because when you
wrong,
say current,
or it didn't
current,
say.
you know, there's a million documents that say the current president is blah from
Yeah.
20 years ago. you
Yeah,
know?
exactly.
Yeah.
Like
Yeah,
he's super
yeah.
old and now you're pulling.
How do you know? You have to say
That's just the.
2020,
true at some
who is
point.
president in
Yeah.
2023? You know, so that's
Yeah.
a slight bug, you know, it's.
Yeah, which, you know, it brings up all kinds of more philosophical thoughts. Like if I was creating my own agent AI assistant, one of the downsides is it trusts the results of any of the tools in the toolchain.
Yeah.
And I can't think of a single circumstance where I would want it to trust the first search results
No, you
off of a search.
so
So
sponsored.
when like maybe that's a backup, like maybe you don't even include that in the tool chain, like I'll trust Wikipedia, right? So maybe pull that out and see if it does better. Not to say that the internet shouldn't be accessed at all, but in this context, the first search result didn't give them the right information. There's no way for it to know. And so it's probably got the right answer because it was in the search result, right? That's where things get really interesting.
It gets more brittle.
Yeah.
Yeah,
And then
we'll try
here's
the
the
rest
one
of
that
them.
we ran, that I sent the posting on. Again, the misspelling, no question mark. I don't
Because
know
in
the
this, you're
exact
kind of at the
date.
mercy of a search engine.
I think Wikipedia has lots of errors.
Yeah, and in this
Yeah.
case, it got
Or
the year wrong.
unfinished, yeah, unfinished, got the year wrong?
It got the year wrong. It used DuckDuckGo search. It didn't think to,
Oh, it got this year wrong.
yeah, it didn't think to check for the current date and.
It did that twice now, yeah, it doesn't
Something, yeah, so even when it's wrong, like this would be a look into to see how to make it smarter. Like I could imagine a level of meta. Okay, again, not to anthropomorphize it, but I'm going to because it's fun. Is we from childhood learn how to approach questions and solve problems through history and through learning, right? And so in this directed cognition, we've hard-coded the cognition steps. The cognition steps themselves aren't something that is learned or picked up. So I could imagine
Right.
an extension to this where the cognition steps aren't hard-coded so much as stored, and that those stored examples, so turn it into few-shot learning, the examples that work are stored and given a higher score, and then as time goes on, the approaches to solve those classes of problems, the results improve because it has built up its own corpus of successful React strategies, right? Again, super exciting possibilities. But yeah, out of the box, the directed cognition in this React agent sometimes it gets the year wrong, sometimes it's 2021. I was getting slightly better results when I phrased it with as of today.
Yeah, as of today.
And I had actually written a chain that just provides the current time and the current day and the date. And I added it into the tool chain, into the toolkit with this prompt, and I didn't spend a lot of time on it. And it didn't choose to leverage that tool in answering the question, and I'm not sure why. Again, it's rife for actually capital R research, for even end users like us who are still with stick, because that's what the experts are doing. They can't write a paper on the structure of a logic and its capabilities just by looking at it. They have to use it and try it, just like we are. Okay, so I think I've talked enough for this morning. But everything that I've shown you is in the Langchain docs. A couple of the examples were maybe customized a little bit, but, and this is one of the reasons I've been hyper-focused on it, is that it feels like another step in the right direction. Directed cognition, wrapping the language model around some Langchain Python code that gives it a fighting chance of getting from A to B is the next step. And then beyond that, while I was just thinking out loud with you guys, making those few shot examples and those prompts more dynamic and getting in a scoring system to be able to evaluate the results, such that over time it collects more examples of successful prompt scenarios to seed it, I think makes things extremely exciting, makes it more exciting. So Yeah, next month, if there's a slot, I'll probably talk about the lava, the image to text generation and pairing it up with an OP light camera and a YOLO to see some interesting results there.
Okay, one question. It seems interesting here that we're kind of reining in, before we were all excited and running just the language model itself and putting a lot of faith or trying to put faith in its answers or trying to change the prompt just to get to more accurate answers by putting in better prompts or whatever. This almost seems like in some ways, you've got this giant model that has all this factual information, let's say, and opinions and all sorts of this corpus of information, but you're in a sense here, you are, putting that aside and allowing internet searches to compete. And so the question is, when is it appropriate to use that information that's already in the model? And if you're not going to use it, why not a smaller model? Then you could reduce the size of this model, improve the efficiency of the everything, all the way down to inferencing on a smartwatch or whatever. But because if you're, there's still some benefit to all that information,
Yep, and it all goes into philosophically and practically what the best approach is to get from A to B.
And when do you cut it off? Yeah, how do you decide, should I do an internet search or do I have enough info in my response?
Yeah, and it could be a matter of self-evaluation because just like on ChatGPT, when you get something wrong, you can pass the output back in and it can fix it. There could be a cognitive step where it generates an answer. You can then ask it to evaluate the answer. And sometimes it'll kick out an answer that it knows is wrong and just asking it. Right, these are all active areas to kind of play with. Getting the size of the model, the 7 billion parameter model is doing things I didn't even think possible. A few weeks ago, before Mistral, getting that agent to work was really hit or miss because it wasn't picking up on the nuances of the prompts the way. And then as soon as I move over to Mistral, every time I'm not saying it's always right, there's a lot of cognitive dead ends where it can get something wrong, but it was able to follow through the prompting for the React agent in ways that none of the other ones would. So I'm pretty comfortable with the 7B model. I'm excited that it makes it available to a lot more people because not everyone has a 24-gig card or an A100 or a data center or is made of money who can run prompts off of OpenAI all day. But this GPTQ, this 4-bit version of the 7 billion parameter model, you can run on a Raspberry Pi 8 gig.
That's awesome.
Raspberry Pi 4, Raspberry Pi 5.
Run on Orange.
That indie board that I used for my NMOVE, it has a built-in OpenCL accelerator and an NPU. So there's possibilities of running it even faster on a board like that. But there are people saying that on the Pi 4, they get about 10 tokens a second. Which, again, it isn't fast, but it's usable. And so the Pi 5 would be higher than that. And then this indie board with either the NPU or just using the OpenCL bindings to the GPU would be even faster.
When does Pi 5, when does that come out?
End of this month?
Oh, it's not out yet, all right. I missed
So
something.
With like the Coral TPU, you think they'll have a way to compile it
Yeah, so it's just got to take that X gamma, right, and then to convert it to run on the tiny TensorFlow Lite.
TensorFlow Lite, yeah. So someone so that could easily be done by somebody at some point.
Yeah, by someone.
And then it will, because like I had a TPU on board this thing forever, and it's just a little board for $40, and it's still pretty good as far as computational, right? It goes way beyond your CPU.
So all right, thank you so much for your time. I know this went long, but
Thanks, Evan. We'll break for lunch.
Thank you.
Pause the recording and continue.
Well, hi, everybody. I have wanted to give you an update on some of the work I've been doing on Big Orange. I did an overhaul of sorts. I had to, for the first problem was that the battery was dying, and it's a rechargeable brick, and I'll show you a picture of that. Well, actually, I could show you a picture of that now. That's this one. So it's this nice, it's a nice brick that produces up to 6 amps at 12 volts. LiPo brick, and it's chargeable right from your wall.
How many amps?
6 amps in 12 volt and 2.4 in the 5 volt USB standard sort of limit. And so I use both the 12 volt and the 5 volt for the lower power thing, so that you've got a good amount of power there with both the 12 times 6 is 72 watts, and then the 5 volt one. So that, I don't know if I abused it or what happened, but it kind of, I mean, three and a half years or so, it started to lose. Plus, I found out that, I did a more thorough analysis of my power. So my power consumption and needs of the robot, and so I had conversations with Sergey and Carl about power consumption and voltage regulation. And here's the orange with the top off. I had to totally go down. I didn't have to disassemble this layer. I was able to do the battery replacement without doing that by getting my hands in here. It was a little tight, but I was able to replace this battery. And so talking about, I kind of, in this current incantation, tallied up all of the power needs, and it turned out that, I wanted to see how far am I off from 72 watts and all that, and the different voltage requirements. So, in this finished version, so to speak, of Orange, and I decided I needed a voltage regulator, because, I found out, for instance, that I'll go through some of the new features I added. I added this voltmeter of it's the unregulated voltage, and I ended up adding a regulator, but like the battery on the 12 volt side goes from 9, or actually below 9 even, when it's at its lowest level, like 8 or something, up to a little over 12 during the discharge of the battery, okay? And I realized that my Latte Panda, the main CPU of the system, is, that's this board. It is its input is supposed to be 12 volt, I think 11 to 15 volts is recommended. So I was low volting that in the latter stages in the last third of the battery's charge. So I decided, and then I also have a USB hub, a 12 volt USB hub, which is it's right here. The 12 volt USB hub I wanted because I have more amps on the 12 volt line, so rather than a 5 volt one. So it has its own buck converter in there to convert from 12 to 5, but that's great because then I can use those amps for that. So that thing is supposed to take 12 volts in, really. So I ended up deciding on a regulator, and I found a place and mounted it here. So this device, which is made for a golf cart, for lights or whatever, but you can get them off eBay, and this will take anywhere from 8 to 40 volts and turn it to 12 volts. And it will do buck and boost. So it has some capacitors in here, and it's got a heat sink.
What's it called?
This is a buck boost converter.
A buck boost, all right.
Yeah,
that's
buck
different.
boost, or a regulator.
Have you looked at the efficiency of it?
Yeah,
Over
and
the range?
efficiency was, well, over the whole, you mean, have I done
Yeah, have you
empirical?
profiled it, or? you
No, I
just
didn't
looked at it?
profile it yet, I mean, it's supposedly 96%, I mean, the advertising is 96% efficiency. Yeah, so you lose a little bit of watts in the conversion, but since I'm using it 100% as a boost, not a buck, therefore, it's just, there may be some, some loss, but it's probably lower than if you were bucking. Because when you're bucking, you're bringing down a voltage, and it's gonna have to dissipate that somehow, and usually it's heat.
It's actually, they kind of just pulse it and run through an inductor, and it's a capacitive. So you actually have lower losses when you're dropping the voltage as opposed to increasing.
Okay,
Where
correct
you
me
need
if
a
I'm-
transformer.
So it does, okay, yeah, I haven't examined the analog, I mean, I haven't really studied all the details,
Yeah.
but, so when you're boosting, it's a little less, it's less efficient
Yeah.
than when you're bucking. So I haven't checked that out, but already I'm noticing I'm getting more time out of it, out of the system. So, so I like it, and so let me go over the other big thing I added was this, and I'll show you a video. I added a grasper, a robot claw, and then I moved one of these sonars down to be used by this to grab things. So this was drilled some parts and figured out how to get it there. So I'll show you that in a minute. One of the things I ran into though is I bought a bunch of these servos. They're standard, but they're called high torque, I think, you know, off of Amazon, and they're pretty cheap, and high speed, high torque. But they, I hooked them up here to the this is the Arduino side of my Lada Panda, right? But with the old servos I've been using for 2 years, I never had a problem. But I bought a new batch of the same ones, M95s, a different company, I think, but they started causing reboots. And when I tried on my Arduino, it rebooted every time I did anything practically. So then this is like a servo newbie mistake, I guess, but you have to power those with a separate 5 volt than your output from your Arduino, which can only handle, supposed to only handle 20 microamps or something, or 20 milliamps, sorry, not micro, or maybe up to 50 or whatever. I was pulling out, the thing wants to pull out 1 amp, and so it was blacking out the system. But the old servos I had, same designation, M95, they worked. They never blacked it out. So then I'm like, oh, well, I was doing it wrong the whole time and got away with it. So I rerouted the power down from my power source instead. And then I had to learn about, dual grounding, connecting grounds together and that sort of thing. You have to connect you have to connect the grounds. You obviously have, of your data line's coming from your Arduino, so you need a ground from the Arduino so that can sync itself. And then you need a ground for the power that's matching the level of the 5 volts. So you need 2 grounds, and then you connect them, and then it works. So that's like a sort of electronics, more of a beginner.
Jim, how much are you using the Arduino? How much?
How much? You need power or what?
Well,
I'm using it a lot now. It's used for all the
Okay.
4 servos, and
what I'm saying is
it's a built-in Arduino. It's part of the.
okay, if you run it at half the frequency, you can run it at a lower voltage, half the voltage, almost.
Oh, really? I mean, I don't
In
need
other
to
words,
do
a
that.
5 volt will go down to 2.7.
Oh, didn't know
So
that.
in other words, if you can do 3.3 volts, you gain the difference between those two of energy.
Oh, you mean you're not using as much, basically?
Yeah.
Now, I can't do that here because this is a Latte Panda with an Arduino built in on the board. So I have no, but if I had a separate Arduino, then I could do that. This one, you have to feed it 12 volts to the system.
Feed it 12 volts, depending on how much you want the Arduino to work, say.
No, but I mean, this is a PC.
It's built
It's
into
a single,
a board that's computer.
Right, but it's just got a 32U4, I think, on it, on the board.
is that
So
a
technically
voltage
it's-
regulator?
No, it's the actual 18 mega chip.
Yeah.
So
It does, yeah.
32U4, yeah, it's a USB compatible.
Oh.
So that's why they would use it. So he's right, you could do that if you want to optimize your power efficiency and all that stuff.
Right, but I don't have a separate power input, I don't think, for the Arduino.
No, but if
board.
you cut the clock in half, it automatically uses less power.
Oh, I see, cut the
Yeah.
clock in half.
Yeah.
Well, that's interesting. That's good to note, because I am tight on power. Well, let's move on though, because I don't want to take too much time. I added a button panel here, and this is like, I bought this a long time ago, and I'm like, I really would like to be able to just press a button on orange and have it stop moving or load a map or whatever. So I've programmed these, I got these buttons and is set up, and now I have those. And it's a little more challenging to program, because all this is from Python, right? This is an Arduino type of keypad where you're just connecting, but when you press a button, it's grounding that line or whatever. And but I like to do everything in Python, so all of it's going through my favorite serial communication protocol called PyFermata or Fermata on the Arduino. So Fermata is a downloadable, it's a free software GitHub project that handles all this stuff for you, controlling servos, controlling input lines, output lines, all your Arduino stuff, or most of it, over serial. So and then you have a client on your PC side, and you can just declare this is a servo on pin 8, and then you can just give it read and write commands right from Python. It's very convenient. Use that?
Yeah.
I haven't found many people that have used it other than me, so I'm glad to see, because it's easier than writing your own serial interface. And I don't want to, I have to communicate from my PC Python environment to get, to control all these servos, right? I don't want to, it's no longer an Arduino only project. This is a full system, right? Anyway, so that takes a little bit of effort, but yeah, it's worthwhile. So I did that. There's a close-up of the claw, and here it's another shot, and it's showing you where I'm using this OAK-D in my the video you're going to see in a minute, where I find the bottle and pick it up basically. And so I figured, well, I've got this low one and I've got the upper one, which you see here. And so when you first see a bottle or some object, I'm using the high one, then I move close to it, and then use the lower one, and then get a close reading on it, and therefore the depth or the quality of the measurement is going to be more accurate. And then I go as close as I can before grabbing. But it turns out this is one of the hardest things. It's the hardest thing I've done with Orange is try to get it to go up to an object and actually grab it. It's very challenging.
Jim, are you using any MOS chips?
No, I don't think so.
They work on a voltage principle, and they draw much less energy.
Right, but that's
Those are generally 3.3 volts.
yeah. But that's more on your microcontroller level.
Well, in other words, I think some even go for an amp or something like that. In other words, look it up in the book and see what.
Right, but yeah, I mean, well, let's talk about that afterwards. So, now I'll get into the videos, show you. So, just last night, I made a funny video. We'll show them both if we have the time here. So, so I set this up in my, in order to, this is the experiment I've been trying and working on for, during the month, trying to get this, to work. Before and after the battery replacement and retrofit of some of these things, I've been working on this claw thing, trying to get it. Then I had to take a break because the battery was dead. So then I kind of got back on board with this, and this is as far as I've gotten. So let's check this out. Oh, should I? Let me redo the share just so I'll do it right here.
Hey, quick question, after all that and your regulator and all that stuff, you're still using the same battery and it's good enough still?
I replaced the battery, so I figured I didn't want to go in and do work on the thing twice, so I'm going to use that old battery and see how good it still is for other things as a bench supply. But it seemed like I had killed that battery, or at least with Orange's situation. And I thought, well, I might be able to use it with a regulator better, but I think the regulator is really helping because I was able to go down to like 8.9 volts and the PC is still running, and I can, with that little LED display, I can switch the wires and look at the regulated voltage really quickly. I made the wires really close. So, and that was, when I looked at it, it just stays solid at 12.1, even though the unregulated is going up and down when the servos turn on and the PC boots up, or it just is, I really like having I like a steady stream of voltage, and that's what the PC was. And all the problems were gone I would be at the point where Orange would start taking off with his servos or have to send more power because it got caught on that cable protector, and then the PC would go off. It just lost power because it drew too many amps and the voltage dropped. Well, no, but I didn't want it. I mean, I don't want it to go off. So it was going off because the voltage dropped too low. Anyway, so I'm definitely into having a regulator, and even if it costs some wattage, it's better. I mean, it's going to allow my system to run longer because of that fluctuation is more of a killer to the PC than just
the regulator chips themselves for usage where you do want a constant voltage, probably a couple bucks.
Yeah, I mean, I paid like $20 for this whole unit. It's very convenient.
But in other words, sensitive circuits, having their own regulator, I mean, you all kinds of garbage on the power end.
Yeah.
Fine.
Yeah, well, I mean, the thing is, this is a little bit of a redundancy because my single board computer already has a regulator, 11 to 15 volts. The SlamTech board, I didn't even connect that to the regulated voltage because it takes 9 to 20 or something. So, and then, so there's already regulators there, but I wanted a better regulator, that would cover a wider range than the single board computer.
Oh, yeah.
And for the power, for the USB strip, that is supposed to be 12, even though it's going down to 5, it has a regulator, but I just prefer to put a 12 on that, or to feed it regulated 12, because that's what it's designed for. That's what the plug you get when you buy it is, a 12-volt wall wart, and those are pretty good. Anyway, let's play this video.
Hey Orange, retrieve the bottle. Okay, I'll search for a bottle. Okay, I see a bottle. I found the bottle. Now I'll retrieve it. It's too close.
Does the bottom have to be out in the open or could it be against the wall?
Oh no, this is and this is like a first. This is a first.
I have the bottle. I'll bring it back.
No, first.
I'm going to the origin.
That's right, yeah.
Like turn right there, but and here's where things start to pretty much the the rest of this is the fun, slightly situation. I'm hooked up to the Langchain system, so it's using sonar as an obstacle avoiding, and I've actually covered the sonar by grabbing the object.
Oh, wow.
So I'm blocking it, so it's doing all this dance and trying to avoid itself. So I'm like, all right,
You need a second sonar.
well, no, you see that the thing was that's the sonar for SlamTech is designed and it feeds into their obstacle avoidance without my choice. So I just did that for convenience because it was already hooked up and everything, and I just needed to do a little software. But in the future, I'm like, all right, I'm just gonna unplug from there and plug it directly to my Arduino. But it's kind of funny that it did, because it's actually took me a lot of hoops to get the info through the SlamTech stuff from that sonar. You know, it's more effort than if it came right from the Arduino. Or well, the Arduino would be over serial. The other one is from IP or over Ethernet and that sort of thing. But
Yeah. If you want to find an object, just put a retro reflector on it, and then use a laser diode.
oh yeah, you showed us that. Well, I remember seeing that. And here was a near success.
Hey, Orange.
I'll just skip to this.
And that's good.
Can you tell us how do you, so I know you get close to it through the SLAM and the navigation and stuff, but once you found it, you gotta actually go to grab the bottle. Are you using your regular navigation there, or are you doing some sort of closed loop or something where you home in on it and adjust while you're reaching toward it?
Yeah, the latter really. So the first part is I can boot up now and show you the what it sees out of the screen, but what it's doing is it's using the OAK-D, sees the bottle, and then it gets the depth, goes up to it, and then switches to the lower OAK-D, does that again. I figured might as well use both because this one can't see over the tray very well. This one's low and I come up, then I use this to get within grabbing distance essentially. From there, or I may just go for the capture. I found out that I'm having a lot of trouble trying to use this sonar because it seems to only, with a small bottle like that, it only catches it when it's getting really close.
Use a retro reflector.
Yeah, maybe that would be better. I mean, but
those lasers are just marvelous. And you modulate it.
right, you have to receive, you have a transmitter or receiver, right? Or
Well, it depends on how you want to receive it.
but you aim the laser, well, the thing is, this is an object in a moving robot, so.
Well, in other words, you do it like that, and watch for the blip, and you grab their angle, shoot right directly at it.
Yeah, the reason I use sonar is because I had success with the Lego robot, moving the cans and all that. It seemed to work well, but this one.
Your orientation is wrong.
Yeah, well.
It should be vertical.
This one, I aimed it down because
The two eyes should be stacked.
See, that way it'll just
Oh.
table legs and objects.
You can do that with these. Why didn't I've only used them like
Rotate at
this.
90 degrees.
Yeah, for the bottle, it's thin, so.
Yes.
Yeah, and also you're gonna have the right location here, you got the triangulation problem with everything.
Right, I mean, this has worked in the past, like, I guess for, like, a soda can is wide enough, but my claw can't fit a soda can. Yeah, I'll try changing the orientation for sure. But yeah, so then, anyway, to answer your question, based on the lower OD measurement, then I either go in for the capture or I go with as close as I can, and then I use the sonar to measure the last bit, and I will go back and forth. But that's been very hard with this orientation. I didn't even think about that. I've just been always see these in horizontal configuration.
Zero was used kind of like tiles.
Yeah, because they look, yeah, like.
See, that's the idea.
Yeah, but in this what's that? In this application, it's a perfect thing to put them vertically, because that would be, because I want to get to the midpoint of this claw. That's what I want to measure. So, yeah, that's why I come.
point.
Yeah, thank you for that. And, yeah, so that was my attempt, and
Lasers 100 to 1,000 feet.
so, yeah.
Hey, Orange,
This is
retrieve the bottle.
It's a funny blooper reel.
Okay, I'll search for the bottle. Okay, I see a bottle.
Oh yeah, this first one is someone suspect that Geoffrey John had.
I found the bottle.
So that's the top one, and then the bottom one. Okay, it opens up.
Sorry, I could not get the bottle.
He gave up early, and then he's like backing up. This is doing like.
Sorry, I could not get the bottle.
And then he rebooted. Yeah, that's a panda. I just measured the pressure on it. Well, see there, I turned the camera away and then it actually got closer. Oh, and this time, yeah, this is a little bit of a so that.
Give me a beer right there.
So it's a work in progress, but yeah, it seems like I have to situation where you're kind of hitting up a roadblock and then you need some new advice like changing the sonar or also getting rid of that, changing the way this sonar works. Obviously, I need to plug it into the Arduino, not bypassing and using obstacle avoidance sonar to do this, because that's kind of. I knew I was going to hit a wall eventually, but I was postponing. So, any questions? But yeah, it's been a lot of work.
On your jaws, to get them closed, you just buy a laser chip receiver and put a white surface there. And so, it sees when the object goes in, or, receiver on this side, transmitter that side goes in, knows it's closed now.
Oh yeah, well, I mean, currently yeah, that might be a good idea. But currently I just use the sonar. When the sonar says it's less than 3 centimeters away, I close the
Have it
jaw.
open this much, and when it goes in, bang, grab it.
Yeah, I mean, I'm using the measurement of the sonar. When it drops below 3 centimeters, then I close. That's worked reasonably. But I'm having a lot of trouble, like I said, I think because of the this orientation is wrong, and it's the thinness of the bottle is too thin for this horizontal orientation. I notice if you move it to the left or to the right, you get different numbers from that sonar in that orientation. So yeah, I was too dense to think about rotating it. Anyway, thank you. That's it for me.
All right, thanks, Tom.
Council President. Ellen, you're up next.
All right, so it came up during my talk this morning. Just super quick. So I've recently been proselytizing about how awesome running Python code in VSCode using Jupyter Labs notebooks. So let me show you exactly how to set that up. So firstly, in your Visual Studio Code installation, go to your extensions and search for Jupyter with a Y, and you'll find a whole bunch of stuff that comes up. You'll want to grab the ones that are marked Microsoft, and just go ahead and install them, and it'll tell VS Code about the file format and then how to open up and see them correctly. It just takes a couple of seconds, and once that's done, you can create a new file, and you have an option in the list for Jupyter Notebook. We'll go and we'll save this, hit Control S for save. We'll give it a oh, there it is right there. Okay. Save as. See, it's given a good title. Let's switch that cell from Python code to Markdown. Super easy. Then we'll click on OK. Welcome to Jupyter. We'll create a second cell down below, and we'll say that this cell is code instead.
Ooh, this is really nice. I've never authored one of these, only used them.
Wait,
It's
are each
like-
of those boxes like containers?
Yeah. So text. So when you start writing programs in VS Code, you get context code completion. You can right-click and look up how methods are created. There's all kinds of fun. You can run the code from VS Code. You can debug it with breakpoints. Super awesome. When you move over to Jupyter Labs and Jupyter Notebooks, you can break down your code into sections and run each section separately, which makes it really handy for iteration.
Yeah.
Except that you don't have that code completion and code lookup and all those things. But if you combine the two, oh my goodness. Oh my goodness. So we'll select Langchain. I think I got it right. And so just going through, you create, they're exactly what they are. They're individual cells. The cells can be anything, but to be honest, you're going to do markdown cells, which is markdown language to describe stuff. 1 hash is title. 3 hashes is a subheading.
You said markdown, not markup?
Markdown, yep.
Yeah, Markdown's another variety, another flavor.
Yeah, same
Oh, I'm
thing.
not familiar with that.
It's simplified markup.
All right,
Yep.
I'm something new every day.
And so you get all the benefits of code completion and lookup, being able to segment, to be able to iterate quickly, because loading large language models takes time. And if you had to rerun the whole script every time you had to correct a typo, you'd be there all day. Something that I've done, because I usually do the right thing last. With this style of code and development, you can load in the stuff that you want to, and then iterate quickly by rerunning the cell that you want, and then save it out. You just save it out and you're good to go. So real whirlwind introduction. Sometimes there might be an additional Python module. Just go ahead and say yes, it'll install it automatically. But really, all the magic is telling VSCode you're going to be using Jupyter Notebooks, and then whether you're downloading the notebooks off the web, anything with the IPYND file extension, it interprets correctly. Changing the style of a cell is as simple as flipping the and switching down from usually Python and Markdown are here too. And aside from titles and bullet points, it supports all of the functions of Markdown, but I usually don't go much past
The
that.
Markdown is very easy to use. It's like been around for years now.
And so, kind of the game plan is you can get this started in Jupyter Labs Notebook, get your code working the way you want, and then once you need to turn it into like a module or a script, just copy and paste the code out and you're good to go. It's a very quick way to understand how the code works and to iterate. You still have your context stuff for definitions, declarations, references, all the fun stuff of VS Code, and segmenting your code into individual souls to run separately. So you can get something right without rerunning the whole thing.
Well, a pro tip, Shift Enter is the best thing to know here, because if you click at the first one, Shift Enter executes it, and it gets the next one ready. So you just hit Shift Enter, Shift Enter, Shift Enter.
Okay.
I learned this from going through the the sort of AI Jupyter Notebooks that they publish for you to go through, and that are big long things, and you can just keep. Oh, actually, it was also it was from my course I took, like Coursera or whatever. I think Coursera, and they taught you can go through even all the documentation ones. If you just hit Shift Enter, it skips to the next block, and if it's an executable block, it executes it. You don't have to. I'm a person that tries to minimize mouse clicks and carpal tunnel.
So yeah, that was basically what I wanted to share with you guys today. Thanks.
So, and ROS, you're up next.
All right, thank you very much. Well, once again, thanks to the group for hosting the meeting. I've like many of you, I'm sure we learn from each other, and that's particularly valuable to me to see the interesting things all you folks do. Anyway, greetings from the true north, where don't have quite the same number of people that do clever things, but so it's nice to do that. So in the last month or a bit more, with a bit of inspiration from, before I do that, I should mention Alan, a great mention on VS Code. I guess I got into it within the year or so, and I use it now with some of my Python ROS launch file stuff, and I like the auto completion, that sort of thing. And I've just last couple of months I've learned how to use the Markdown, which of course is handy when you're preparing a GitHub. It just takes care of itself, which is a nice part about that. And then one more thing that's worth mentioning, I guess some of you are probably aware, there's a new Raspberry Pi that's been announced, the Raspberry Pi 5, which is reputably 2.5 times better than the Raspberry Pi 4, and even more better. Apparently, it's going to be available from the all the usual suspects from the U.S. vendors. So if you've not been able to dive into using that controller, well, it's you can look forward to that. Getting one, if you haven't got one before already, in December, I believe, is when they're saying that it should be available. Anyway, so in the last month or so, with a bit of inspiration from the always enthusiastic camp, we decided to look at go back to Turtlebot, and I decided to renovate my 2011 era Turtlebot that first got me started into this whole crazy business. And I found some code that drives the base on let's see, I guess we could there we go. Yeah, I can focus me on this. So this is a Turtlebot. Originally, doesn't seem to like it, does it? There we go. Right. So that's right. So that's a Turtlebot with one of its layers missing. And inside, I've now equipped it with, you can see there's a Raspberry Pi over here on the side. That's an RP1 LIDAR there, and an Oak View camera on top. And so the code that runs the base, which is of course down here, and I had to, as we were just heard, the power system for a robot is the biggest pain in the neck, and I had to, of course, buy a new. After 10 years, I had to buy a new battery for the for the base, which ever present. You can buy it from Amazon. So I was lucky to get it run. Anyway, I loaded the code into the and I run the whole thing off the battery. Let's see, I have a light here actually that probably makes everything a little better. Right. So I have a battery, just a battery pack that runs everything. It works just fine. So let's so it run the Raspberry Pi runs with it's loaded with Ubuntu 22.04 and equipped with ROS Humble. And what we Camp and myself and Dr. Bot have decided we're going to call this thing a mock turtle, and make it. I think Camp's going to put together another one of his books and on how you can build different kinds of turtle bots with existing hardware. In my case, I'll use the original Create base, which you can't buy anymore, but you can buy a Create 3 from iRobot, the iRobot company. It's cost more than it did back in 2011, but it's still pretty effective, pretty cost effective when equipped with a Raspberry Pi 4. And then of course, Dr. Bot is a big fan of using the Needle base, and I think you've seen some demos from myself and from Camp on putting together a ROS robot on that. Anyway, so far all I have got it to do is tell up. So here's my desktop. Right, it's all fired up. You're looking at the image from the camera, and frankly, that's all the OAK-D does. Ultimately, I'll probably take advantage of some of its image recognition capabilities and have it do stuff with that. Down here is the image from the LIDAR. This is the edge of my room. And I have not got the Nav2 integrated into it yet. I've discovered that the stack that runs the base the parameters don't quite match up with what's required for the Nav2. So my work in progress is to get the two to work, and then I can navigate away. And of course, I run the whole thing with my ever handy controller, and I'll just do the simple. Every robot demo has to have a robot that runs. Mine will run across the room. Under my control, hopefully. So there we are. A mock turtle part A. Remainder of it. Oh, hello there. Part 2. One of the things you'll notice is that there's a huge lag with the camera. And that's because I'm using just the default resolution of the camera, which is around 1024 by whatever it is, 800, I guess. And that's a bit of a load on the network. So I'm going to change the parameters to bring that down to something usable, like 300 by something, and it would probably reduce the lag. So there we go. Mock Turtle Part A, Part 1.
So that was a retrofit of your old base, huh?
Correct. Right. The code I use is from a organization called Autonomy, which is a piece of the engineering department in Simon Fraser University. I think it's a student project there, and they've supported the base with just telop over the last several years. It was first posted with ROS1 Noetic, and just 3 or 4 months ago they posted ROS2 Humble. So this is one of those miracle things. You just loaded it into the Raspberry Pi, compiled it, and the damn thing worked. So there we go. I sure would like to, you're a real inspiration, Jim, with your image recognition and having it actually do useful things, which is something my wife always asks me. What good is it? Was this everything? Is this going to ever fetch something for me? Well, certainly that camera has, like yours, like the way you use yours, it would have the capability of doing that. Anyway, so again, the code is autonomy.ca. Autonomy.com. I'll put the link in the chat. And they actually have code that works with the Create 1, the Create 2, which is I guess they don't sell that anymore, but you can probably buy them used. And Create 3 as well. And then of course there's the Turtlebot 4 that's marketed as a commercial product by ClearPath. And they all roughly the same. They all work with the same principle of driving the base with a serial bit stream. Anyway, once again, thanks for the opportunity to show off a little piece of work one does. I won't promise any progress for next month, but whatever.
I've got a comment for Ross. So we're playing with Nav2 and started with the Raspberry Pi, so doing the SLAM and the Nav and the high level, low level, everything. It was overpowering the Pi. So
yeah, I run my navigation on the desktop.
There you go. So you're gonna be
We're gonna another Pi.
Yeah, so
right.
Doing it on a more powerful embedded piece.
Yeah, it's like here. Let me just I'll pull that up again here. This is just a terminal connected to the Raspberry, and what you're seeing here, this is actually the script for the Create base, and the camera is similarly started up from down here and sends messages over to the desktop. So
right, yeah.
And my Needle Turtle works perfectly well with that architecture, that arrangement, and I can even run the Needle Turtle, which is again a similar base to this one, different API, but principle is the same. Anyway, I can run that turtle, and I can navigate with a Raspberry Pi 3, and I even got it to work with the Raspberry, what's this called, 02W. It tends to hang up occasionally with the 0, but works just fine with the 3. All it's doing is the fact that is processing the it's 57.6 kilobit bit stream, and then the image. The image is probably the biggest load on it, and I make sure I knock knock the resolution down.
Thank you, Ross.
Pleasure.
I was gonna say, I try to do things as much on robot as possible, because it makes, when you go on the road, on a road show,
Yeah,
a lot easier than, if you're in someone else's network, it's a lot easier to only have one thing that needs to access the network and not talk to your other thing that has a network too. So I prefer that, yeah.
yeah. Back when I was doing what you were just described, taking my original Turtlebot, whose controller was a small laptop. I brought my own portable mobile router.
Yeah, I bought one of those too.
Sure, and you could, in fact, I found myself in libraries that didn't permit you to connect between two. I'm not familiar with the terminology, but even though you're logged onto the same network with two devices, they don't.
Yeah,
Can't communicate.
Your communication sometimes.
You can't
Right.
do it most of the time. I mean, like you go to some corporation, some company, and they have a network, and your two devices end up on completely inaccessible networks to each other.
That's right. Anyway, so the mobile router takes
Bring
care
your
of it.
own-
Actually, the ROS2 network protocol is significantly better than the ROS1, and it overcomes some of those problems. But anyway, taking things on the road is a separate challenge on its own, for sure. Especially when at a demo in an auditorium with kids watching.
Yeah.
Inevitably something won't work, right? Everybody has their phone out and there's Wi-Fi everywhere.
Yeah, you don't want to do that.
Anyway,
Hardwire it with Ethernet in a box.
right.
Cage.
Yeah, in a Faraday cage. Yeah, that's why I would I have I have two Raspberry Pis in my Nito bot back, and then hopefully that'll cover all, two Raspberry Pi 4s maybe, and that'll cover all the power needed for us, hopefully.
Oh, sure. Yeah, I think you can run navigation on as long as it's the only thing running on one of the Raspberries. I'm sure it'll work. I shouldn't say this, but it probably works just fine. Is that what you're saying? That's what you do, right? But what do you do but as far as the display though? I mean, you need to show your map somehow.
You're asking me?
Yeah.
Yeah. So all that. I mean, the robot doesn't need to display a map, and so when I'm debugging, I'll show a map on a desktop or something. Sure.
Oh, sure. Yeah.
You connect to it, right? Or
Yeah. So
or you subscribe.
I subscribe. Yes.
Yeah, you can just subscribe to it from the
Yeah.
from the desktop or something. Yeah. Cool.
So is there something? All right, so just to carry on a little bit and wrap up the conversation about power and PCs, I came across an interesting post a month or two ago that seems apropos now. Is that balance between onboard versus cloud and cloud local, and the availability of. Shoot. All right, here, we'll do it this way. So, it used to be onboard Pi, it was a great way to at some point, but very limited, and then cloud for everything else. And the Pi 4 came about. The Pi 5 is 2.5 times as powerful on paper and has 8 gigs of memory, which opens up new options. And
power hungry though.
It's actually the Raspberry Pi 5 also has 2 camera connectors. And I bet I haven't seen the code, but that means that if you buy a camera with a with a global shutter, which you can get, that means you can do depth perception with it.
Yeah, and with the OP Lite, you've got the OPs, you have the option of onboard processing too.
Well, yeah, you would end up with. Right. I mean, the OD is a good way to go, certainly, and that's what I have. But the Raspberry Pi 5 has would have that same capability.
You mean if you're global shutter and you have two cameras mounted as stereo pair?
Correct, yeah.
But they'd have to be synchronized global shutters.
Yeah.
Well, I actually, I was just curious, and I Googled that, and it turns out there was a narrative from the Raspberry Pi folks that makes reference to the ability to generate a depth cloud. And there are ROS 2 packages that do that. But I guess the implication, again, to be determined with hardware verification, of course, but the article indicated that you could connect the two cameras to the two connectors on the Raspberry Pi and generate a synchronized stereo image.
Is that cheaper than buying just getting a stereo camera? Or?
Well, it's cheaper than buying the Intel one, but you can get an OT for $150. So.
Or the OT Lite is cheaper ones.
Yeah, it's 150 now, I think.
Is it under?
But but if you already have the Raspberry Pi 5, right, you're into the cost of the two cameras, which are $50 each or something.
One of these delivered today. I'm excited to take a look at it.
What is that?
Oh, the OP Lite?
Scroll down. We're seeing Detroit Nova.
Oh no, what is that? That's not. I am.
You're sharing one.
Oh, you're not sharing the screen.
Just a moment. No, it was working the screen, but let's go back over there. There we go.
Right, 150.
Yeah.
150. Well, you guys gotta get on board early. I bought all these things for half the price.
Yeah, I got mine too. Actually, that all said, I think there's a real benefit to using the OT Lite. The hardware is now mature. It's been out for a couple of years, and the code, they've done a really good job with code. They've well supported by ROS 2, the image recognition. I've actually played around with a package with the OT Lite that can track me, and
yeah,
I believe I can emulate the following functions that Jim, that you displayed with code that is it's open source code that's been written by folks for the OT Lite. So great.
Yeah, that's OP Lite. That's another camera. I'm not familiar with that. Oh, yeah, I might upgrade my latte pan.
Yeah. So just sorry to take up so much of your guys' time. Just to kind of the lay of the land is Raspberry 4 is out, 5's coming up, which offers more horsepower. There are a bunch of independent forms, ports and various functions. This is what I use for InMove for the film shoot. It's got an octa-core, it has an NPU, it has OpenCL support with 16 gigs of RAM and 64 gigs of eMMC, very fast storage, which presents another option. The Latte Pandas, from the original up to the Alpha to the Delta and now the Sigma, have onboard performance at various price levels and performance levels. Sigma's latest and greatest, it's a $500-600 board. But if you need a board with integrated Arduino, it's the only game in town right now. But someone pointed out during the height of the show, oh, sorry, go ahead.
Yeah, well, you mean the Latte Pandas, because all of them have built-in.
Yeah, so this is definitely will suit your bill for various use cases. But now we're getting into verified air territory from my budget standpoint. But someone pointed out in the middle of the shortage that there is an untapped resource for small, small lower power consumption, full featured PCs. So depending on your space and your power budget, these little mini nooks and their offshoots with a full Celeron or i3 or i5 processor might also fit the bill. This not only includes new stuff in various formats, but even repurposing like, depending on what your size budget is, like a used mini desktop for $200. So, you know, when you're looking at, hey, how much bang for the buck can I get for $200? You know, Raspberry Pi definitely fits. There's first and second generation Langchain Panda that would fit. The Indie Droid with ARM would fit. But if you've got the room, these small micro desktop PCs might also get you from point A to point B, which I thought was pretty exciting.
How big are they? Yeah, they've been around, right?
Oh yeah, they've been around.
Well, how come we haven't been
using?
using, well, how big are they? Would they, they're probably bigger than I could fit, right, on this thing. I mean,
No,
Yeah.
they do require a lot more power.
Power
is a big deal.
And
Power.
they like to have the higher voltages, like 18 volts.
Oh,
so-
18. Yeah, see, power is a big deal to me, because, you know, I only have so much room and so for, you know, for battery, and lithium is kind of one of the higher density power sources you could have. And you know, I could probably squeeze more, you know, in a smaller robot, don't want that power to drain. This thing will drain that, it goes to the 38,000 amp hour, milliamp hours, is down in an hour.
Yeah, yep, so when you're looking at, you know, power budget included, then if you expand your search to these little mini NICs and things, you might find something that is a better or equal fit for the same price as going on.
And it might, and if you're saying power, it may be good.
Well, yeah, it's one of the things you want to look at for
Yeah,
sure. Like
but-
some of them, I mean, most of them are based on laptop chips, but they're not built necessarily for low power budgets. But you know, you never know,
Well, that's-
especially in the used market, $100,
Yeah.
$200.
Oh, I see, yeah, it's cheap, yeah.
Yeah.
But the, I mean, that's why the Langchain Panda people have a business in the Raspberry Pi, because those are great low power devices that can run, that are great for robots and lower power situations, whereas
Yeah.
these eat up more.
Yeah, and another middle ground, we use the Orange Pi, I think it's 8
Oh,
core.
Orange Pi.
It's gonna be the same thing as the Indie Droid,
Yeah, a bit medium price, so it's like $200 or something.
like the top level one.
Yeah, so it's middle ground.
See, my Langchain Panda was 250, but with Windows Professional installed.
You're gonna run Windows on Orange Pi?
Windows.
No, I was saying Windows on mine, but not.
Did you run Windows on Pi too?
Yeah, like that kind of thing.
That's a good, yeah, they don't have Windows for, I don't really want to use Windows per se, but I had to for this design because of the, Slam Tech was dedicated to Windows. But
Yeah, so there's all
Move
kinds
on.
of niche players out there right now, and it really is incredible.
I haven't been drawn to the Raspberry Pi lately because there was a shortage. Like, oh, a lot of these other things work just as well.
yeah, we give you
so-
that, they lost your business.
Yeah.
I bought a few of them, but you know.
Yeah, I'm buying the Pi 5. If I can get it.
Oh, yeah,
You gotta catch them all. But
Put it in my drawer of pies.
The drawer of pies.
Just throw it in there when you get it.
I got an original Pi and a Pi 3D and a Pi 3A.
I'm going to drop off now. So once again, thanks, folks, for welcoming me. All kinds of good stuff.
See you next month.
See you next month. Great. It's time for supper. See you all.
Right.
All right.
I have a show and tell.
Oh, okay.
I don't have a whole thing, I just have a picture, I'll send it to you. I'll send that picture to you.
Yes.
So, it's just what I've been working on.
Oh, Carl said some cookies and stuff. But yeah, I don't know whether to upgrade this or retire it, but yeah, I guess I put it enough. As far as I do need more CPU power, so, and the Langchain Panda
emailing it or
Delta,
texting it?
the next
Email
version
right
would fit
now.
right in there.
There you go.
Okay, I emailed it.
And but it's only 2 times to 2.5
Just the
times as
same
fast. That's not worth it much. And more memory. Like I only got 4 gig on this. 4 gig is too small. I've grown out of pretty much grew out of the size of this.
Showed up yet?
Not yet.
I'm still on
Right,
that.
since you
Oh,
used
I don't have very good
Like even double the power.
I need to
that's
go out
pretty
to the
good.
hallway to.
Double the speed,
Yeah, that'll give you plenty of,
Otherwise, next
Some
one.
room for now.
Oh, there it is, got it.
It's
I'll do that.
Python code, it's probably, and
Yeah, that's
And
what I'm working on,
multiple-
that's one of the many things.
multiple things eating up memory and Windows, takes up most of the 4 gig already. It's like, I don't even.
All right, let me go ahead and share the.
Oh, what do you got?
So a long time ago, I, wrote a